Good evening, Abubakar sir. Good evening, Ajit.
കുറച്ച് വെയിറ്റ് ചെയ്യാം അല്ലേ സർ?
ഒരു 7 ആയില്ല. 7 കഴിഞ്ഞാൽ ഒരു 5 മിനിറ്റ് കഴിഞ്ഞ് നമുക്ക് തുടങ്ങാം. പക്ഷെ പലരും 5 മിനിറ്റ് കഴിഞ്ഞേ ജോയിൻ ചെയ്യുള്ളൂ. നമുക്ക് തുടങ്ങാം.
ഗുഡ് ഈവനിങ്. ഞാൻ ആദ്യം പറഞ്ഞ് കേട്ട് കാണൂലായിരിക്കും.
സാറ് പറഞ്ഞ് ഞാൻ കേട്ടില്ല.
എന്റെ മ്യൂട്ടായിരുന്നു.
ഓക്കെ.
ഈ വൈകുന്നേരം കുട്ടികളൊക്കെ കയറുമോ?
ഇതില് ഇൻട്രസ്റ്റ് ഉള്ളവരൊക്കെ കയറും സാർ. കാരണം അങ്ങനെയാണ് പൊതുവെ. ഗുഡ് ഈവനിങ് പ്രമോദ്. എവിടെ ഓഫീസിൽ തന്നെയാണോ?
പ്രമോദ് ഗുഡ് ഈവനിങ്.
പ്രമോദ് കേട്ടില്ല എന്ന് തോന്നുന്നു. പ്രമോദ് കേട്ടിട്ടുണ്ടാകണം. ഗുഡ് ഈവനിങ് നിഷ.
Yeah, good evening. Hi, Ajit sir.
Good evening.
Yeah, good evening.
മിസ്റ്റർ അജിത്തിന്റെ വീട് എവിടെയാ?
ഞാൻ പാലക്കാടാണ് ഇപ്പൊ താമസിക്കുന്നത്. ബേസിക്കലി ഐ ആം ഫ്രം ട്രിവാൻഡ്രം.
ഓ ശരി. തിരുവനന്തപുരത്ത് എവിടെയാ?
തിരുവനന്തപുരത്ത് തിരുമലയാണ്. ഇപ്പൊ പക്ഷെ സെറ്റിൽ ചെയ്തിരിക്കുന്നത് ശാസ്ത്രമംഗലത്താണ്.
ഓ ശരി. ഞാൻ എന്റെ അടുത്ത് കവടിയാറ് എനിക്ക് എന്റെ വൈഫ് ഹൗസ് ഉണ്ട്. എന്റെ വൈഫിന് ഒരു വീടും ഉണ്ട് അവിടെ, ടെന്നീസ് ക്ലബിന്റെ അടുത്ത്.
ഞാൻ അവിടെ കവടിയാർ ശാസ്ത്രമംഗലം പൈപ്പൻമൂട് റോഡില് കോടിയലിന്റെ ഒരു അപ്പാർട്ട്മെന്റിലാണ്.
എനിക്കറിയാം. കോടിയലിന്റെ കുറെ അപ്പാർട്ട്മെന്റ്സ് ഞാൻ ഡിസൈൻ ചെയ്ത് കൊടുത്തിട്ടുണ്ട്. കോടിയലിനും ആർടെക്കിനും.
ഇത് താഴത്ത് അവരുടെ ഓഫീസും ബാക്കി ഫ്ലാറ്റ്സും ആയിട്ടുള്ള ഒരു ബിൽഡിംഗ്.
അത് ഞാൻ ചെയ്തിട്ടില്ല. ഞാൻ കുറച്ച് മുമ്പാ ചെയ്തിട്ടുള്ളതൊക്കെ. കോടിയലിനും ചെയ്തിട്ടുണ്ട്. ആർടെക്കിന്റെ ഒരുപാട് ബിൽഡിംഗ് ചെയ്തിട്ടുണ്ട്. ആർടെക്ക് തുടക്കം സമയത്തൊക്കെ ഞാൻ ചെയ്തിട്ടുള്ളത്.
സാർ തൃശ്ശൂർ എഞ്ചിനീയറിംഗ് കോളേജിലായിരുന്നു?
ഇല്ലില്ല, ഞാൻ കോളേജിലൊന്നും ആയിരുന്നില്ല. ഞാൻ PWD ആയിരുന്നു. റിട്ടയർമെന്റിന് ശേഷം കോളേജിൽ കുറച്ച് നാൾ വർക്ക് ചെയ്തിട്ടുണ്ടെന്നുള്ളൂ. പിന്നെ സ്റ്റാർട്ട് ചെയ്തതും ട്രിവാൻഡ്രം എഞ്ചിനീയറിംഗ് കോളേജിൽ നിന്നാണ്. ഒരു കൊല്ലം അവിടെ പഠിപ്പിച്ചു. 70-71. I passed out in 1970 from NIT, REC Calicut.
ഞാൻ CET-യിലായിരുന്നു. CET-ലെ പഠിച്ചിരുന്നൊക്കെ.
ഏത് ബാച്ചാ?
82-86.
You are a boy for me. ഞാൻ 70 ബാച്ചാണ്. 66-70.
Okay.
ഫസ്റ്റ് ബാച്ച് 4-year കോഴ്സ്. 70-71 അവിടെ അധ്യാപകനായിരുന്നു. പ്രമോദെ അറിയോ?
ഓർമ്മയുണ്ട്, നമ്മൾ സംസാരിച്ചിട്ടുണ്ട്.
ഓക്കെ.
ഏതാണ്ട് 35 പേരായി. ഐ തിങ്ക് വി ക്യാൻ സ്റ്റാർട്ട് അല്ലേ സാർ? ബാക്കിയുള്ളവർ ചേർന്നോട്ടെ.
അതെ.
അപ്പോൾ ആങ്കേഴ്സ് പ്ലീസ് ടേക്ക് ഓവർ.
Good evening, everyone. On behalf of Vedavyasa Institute of Technology and Innova Group of Consultants, I warmly welcome you all to today's insightful webinar on cracks in concrete. concrete is the backbone of modern infrastructure, and understanding its behavior, especially cracks, is essential for every civil engineer. Today, we are privileged to have an esteemed panel of experts from academia and industry to guide us through this important topic. I now invite Professor Divya K, Vice Principal of VVIT, to deliver the welcome address.
Good evening, everyone, respected dignitaries and dear participants. Today we have a webinar on the very important topic, cracks in concrete. First of all, for that session, I welcome Dr. P.R. Sri Mahadevan Pillai, Chairman VVIT, who is presiding over this function. Welcome you, sir.
Thank you.
Next, I would like to welcome all the panels who have joined us, who have contributed their time to be with us. First of all, I would like to welcome Dr. K.A. Abubakar, Chairman, Standing Committee, MES Engineering and Architecture Colleges. Welcome you, sir.
Yes, thank you.
Next, I would like to welcome Dr. Raghukumar C., Retired Professor, Government Engineering College, Thrissur. Welcome you, sir.
Thank you.
Next, I would like to extend a warm welcome to Dr. Adira Gopinath, Assistant Professor, IIT Palakkad. Welcome you, ma'am. I would like to welcome Engineer Ajit D, Managing Director, Habitat Palakkad. Welcome you, sir.
Thank you.
I extend a warm welcome to Dr. Nisha A.S., Assistant Professor, NSS College of Engineering. Welcome you, ma'am.
Thank you.
Next, I would like to welcome Engineer K.O. Pramod, Director, Structures India, AMZ PMC Services Private Limited. Welcome you, sir.
Thank you.
Next, I would like to welcome all my dear colleagues, my dear students, anchor for today, Ms. Lakshmi Nitina, and who's delivering the vote of thanks, Krishnendu VP, Assistant Professor, VVIT, and I extend a warm welcome to all the participants who have found time to join with us. Welcome you all and wishing you a warm very good evening. Welcome. Thank you.
Thank you, ma'am. Now I invite Dr. P.R. Sri Mahadevan Pillai, Chairman of VVIT, to deliver the presidential address.
Thank you, Professor Divya and Nitina. Good evening to all of you. We are still having members joining us. So that will continue for 5 to 10 minutes more, I hope, because that is the usual routine. So we wanted to start at 7. People will start joining from 7 and it may go up to 7:10, 7:15, but it's quite known to all the panelists also. So today we are going to have the discussion on cracks in concrete. All the panelists are here. I don't know whether Dr. Adira has joined. All others have responded and I've seen them on the screen. Otherwise, she'll be joining anyway. I'll remind her. And this discussion on cracks in concrete was actually initiated some 10 days back when one of the alumni groups of the NSS College of Engineering started a discussion on this, following the cracks of building which were constructed for rehabilitation of the Wayanad victims. So they started the discussion as to what is the reason, why it cracks, what are its problems. And I was observing all these things, then I suggested in the group, I'll organize a webinar on this matter. Those of you who are interested in this can join. So some of them also have joined, not all. So it has become a public concern then. That is why this discussion can throw some light on such social issues where cracks are becoming a news and a concern for the government and for the people. And concrete is such a material. Theoretically saying a concrete without crack is practically difficult because, especially in reinforced concrete, we are combining two materials. One material with a very high elasticity, with modulus of elasticity as high as 2,100 kilogram per centimeter square or 2,100 tons per centimeter square, which is quite high. whereas the other material has not got a tensile strength or elasticity anywhere near around. So when it is subjected to load, this differential behavior of the material is bound to cause cracks in concrete, especially in reinforced cement concrete. Whereas in plain cement concrete, excessive loading, differential settlement, improper materials, quality of materials, all these things may cause the cracks. So we will have all these discussions here. I will not be telling much right now because I have done a lot of research also on this part. Because at my PG level, the thesis was on partial rigidity of joints. We ultimately found that any design has to be done on cracked section theory. Then at that time, the cracked section theory was not used in design. But nowadays, we have got a cracked design procedure itself. So if we assume that we can make a concrete without cracks on it, that will be very difficult. But the point is whether it will affect the functionality of the concrete, whether it is RCC or PCC. So that functionality part is more to be concerned. Normally in cracks, we say concrete will have cracks by different methods. By structural design may cause one, insufficient design, insufficient reinforcement, insufficient thickness, reversal of stress. All these things may be there in structural design. Corrosion may cause crack because the reinforcement may expand, spalling may happen, it may break the inside. Then flexure at unwanted places, whether negative or positive, may cause. And then the creep in the concrete, again another issue. Then the thermal stresses, again another issue. All these things are one by one the factors. I'm not going to the theory or the caudal provisions or anything like that because I feel I'll reserve my technical part till the end of the panel discussion so that when everything is discussed by the expert panelists, if something is missing out, I can add on to that because I've been also in this field for more than 4 decades, dealing mostly with concrete and design. This much only I am talking right now because any technical addition, I think we'll have at the open discussion time so that I am not taking much of the time of the panelists. Because panelists we have got from different areas, specifically, we have chosen the people who have got expertise in different areas. Dr. Abubakar is basically, sir, you have been mostly in department as well as in academics. So you are a mix of both. And a practicing engineer or designer. And Dr. Raghu was mostly in academics only. He retired from the Government Engineering College. And Dr. Arudi, I don't know whether she joined right now. Earlier she was not here. Maybe would have joined.
Yes, I am here.
Yes, you are here. While introducing, you are missing a bit. Okay. She is a researcher in this area. Thank you for joining. She is a researcher in the area. And so she has got some credential publications in this matter. And then we have got Engineer Ajit, who has been very active in the construction sector. He was in the Nirmadi Kendra as a project manager. Then he started his own company and he's heading his own company now, which is into construction, which is into contracts and consultancy. And we have got Dr. Nisha, who has done her research. She is a doctorate in structural engineering. So she has been teaching this subject for a long. And Engineer Pramod is one of the most well-known structural designers in this part of the country. He has got a lot of clients. And these are all experts in different areas. I would like to listen to them. And as I told, if something is missing in those discussions, in the open discussion time, I can also add up. Because specifically, this is one of my expert areas where I used to give a lot of webinars recently on this topic. But this being a mixed session, I want more to listen to all of you experts. So, Andres, please take over.
Thank you, sir. It is my honor to introduce our first panelist, Dr. K.A. Abubakar. He currently serves as chairman of the Standing Committee of MES Engineering and Architectural College and is also the chairman of Baker Associate and Consultant, Kochi. With vast experience as a chief consultant in structural and foundation engineering and as a mentor through Baker Academy, he has contributed immensely to both academia and industry. His previous role as secretary of MES College of Engineering and Technology further highlight his leadership in education. Our next panelist is Dr. Adira Gopinath, Assistant Professor at IIT Palakkad. She is actively involved in teaching and research in civil engineering, contributing to advancing knowledge in structural engineering and related domains. I am pleased to introduce Dr. Raghu Kumar C., a structural engineer and retired professor from Government Engineering College, Thrissur. With over 14 years of industry experience and 20 years in teaching, he brings a rare blend of practical and academic expertise. His proficiency in structural analysis, seismic design, and tools like STAT, PRO, and ETABS make him a highly respected professional in the field. Our next expert is Engineer Ajit D., Managing Director of Habitat Palakkad. A chartered engineer and registered valuer, he has extensive experience in project management, valuation, and consultancy. He has also contributed as a speaker and columnist in various technical forums. I now introduce Dr. Nisha A.S., Assistant Professor at NSS College of Engineering, Palakkad. With 15 years of teaching experience and a PhD from Indian Institute of Science, her research focuses on structural health monitoring, dynamics, and stochastic process. She is also actively involved with the Institution of Engineers. Our final panelist is Engineer K.O. Pramod, an international professional engineer with over 30 years of experience. He specializes in infrastructure projects, including bridges, high-rise buildings, and industrial systems, and is currently leading Structures India ANZ Project Management Services Pvt.Ltd. With such a distinguished panel, we are sure to gain valuable insights into causes, prevention, and repair of cracks in concrete structures. Let us now move into the panel discussion. So for that, I warmly welcome Dr. K.A. Abubakar to be a part of our panel. Sir, please.
Thank you. Dr. Sri Mahadevan Pillai, Chairman VVIT, Professor Divya, Vice Principal VVIT, and Ms. Krishnendu, Assistant Professor VVIT, Dr. Raghu Kumar, panelist, Dr. Adira Gopinath, panelist, Engineer Ajit, panelist, Dr. Nisha, panelist, and my friend, Mr. Engineer K.O. Pramod, structural engineer. First of all, I am, as so many academicians are here, I am not going to the technical or the theoretical part of the cracks in concrete, but I want to put the time available with me. My experience, 55 years plus experience I have got the industry, the construction industry, I've got 55 plus years of experience. Some of the experience I will share with you with this short time. The first one is the shrinkage. There are so many types of cracks. First of all, concrete has two qualities. One is it hardens and it cracks. Concrete will crack, as Dr. Mahadevan Pillai said, it will crack. But all the cracks are not dangerous. Some of the cracks are dangerous. Some are, very superficial cracks, and they are cosmetics nature. So let us see one of the thing when we first put the concrete on the site, the shrinkage cracks happen first. Shrinkage cracks. How the shrinkage cracks happens? It is due to the evaporation of the water from the concrete, especially in this hot summer. It may be common in many other places. And one thing, we can control this shrinkage cracks to some extent or fully by using the proper cement, which is the best cement for such constructions. I think for slab construction, PPC is all right for all types of constructions, and especially low-rise buildings, PPC is good for all columns, foundation, beams, everything. Of course, multi-story buildings, we may have to go for 53 grade of concrete, cement. But you can see that most of the people are using 53 grade of cement even in this hot summer for doing the slab concrete of their houses. So that is not required for a house construction. The best cement is PPC, and best PPC cements are available in our markets. So, or you go for 43 grade, please don't go for 53 grade. 53 grade is heat of hydration is very high, and the shrinkage cracks will immediately happen. I have seen it many times. So, and for other cement also, shrinkage cracks may happen in this hot summer. So, what to be done is either you cover immediately, putting the concrete, cover it with a plastic sheet, or spray water after the initial setting time. Spray water on the surface. Don't pour water, only spray water. That is control the shrinkage crack. The shrinkage cracks are not dangerous to the structure. So you can control the shrinkage crack like this. Then the other type of, another thing I have noticed in my experience, in my service is the cantilever, the failure of cantilevers. Cantilever, I have seen many cantilever sunshades have fallen down or broken down. And one thing I have to make a point to you now is, when you do concreting for cantilever beam, the cantilever beam's depth is, if it is more than 30 centimeter, you should be very careful. When you put, say, 45 centimeter depth of cantilever beam, if you pour concrete, the fresh concrete, the concrete will settle. And once it settles, the reinforcement, the main reinforcement is at the top of the beam, is not. Even now, people with MTech with CGPA 8.95, as once told me that the main reinforcement of the cantilever beam is at the bottom. There are people like that even now. But still, I tell you, it is at the top, and when the concrete is filled, it settles at the depth. When the depth is more, it settles down. So you won't get the bond below the reinforcement. So there will be a bond loss for the concrete and the steel. So cracks may appear immediately. Immediately cracks may appear. Longitudinal cracks may appear on the surface. You can see it. But if you control, if you do it properly, when it comes, the depth is more than 60 centimeter, you would be very, very careful in doing the concrete. Because the concrete should have the water cement ratio less. For that, reducing the water cement ratio, you can add admixtures, and you have to properly compact the concrete, and proper cover shall be given, or else this gap will be more. This gap can be the settling gap, maybe 30 to 40% bond loss it can create. 30 to 40% bond loss it can create. So you can understand the gravity of the situation. So you should be very careful in doing the concrete beam, cantilever beam concreting. That is another thing. Another thing is the strength loss is in our site. Now almost all sites we are using only crushed sand, M sand. M sand is a brand name, but still I use that. Crushed sand we are using. So in crushed sand, we feel that there's not any dust. But most of the sand, they are single word sands, and they contain a lot of silt. You know, silt is those particles which are less than 75 micron, is it not? So the silt to small extent may not affect the quality or the strength of the member. But if the silt content is more than say 5% or 10%, the strength reduces considerably. Up to 5%, it is almost okay, and above 5 to 10%, it is good. But above 8%, you can see that the strength reduces. So avoid silt. You can easily find out the silt content. I never permit silt content more than 10%. Even double watts fine aggregate for the M sand you receive from pressure have more than 10% silt content. Every site, there is a mechanism for my sites for measuring the silt first before using for the concrete works. So in the site, you can very easily find out the silt content with a glass, simple glass, I use a small glass only for bottom and top, same diameter glass. If you use, you can easily find out the silt content. I have put a video in my YouTube channel about this, how to find out the silt content in the site. Okay, that's a very important thing. And the silt content in the concrete reduces strength, and it creates leads to cracks. That's another reason for cracks. So then another thing is that you are in certain cases, people have a feeling that if you use more cement, the strength increases. It's a wrong information. Actually, in the Kerala PWD data book, there are many type of mixes, and one mix is 112. 112 means they given 540 kilogram of cement, where IS permits only 450 kilogram. So excess cement, and I have seen that, I have also tested many types that it does not, if you use 112 mix, it will not get the strength of 124 mix. Because there's no meaning in using excess cement in the concrete. So if you use more cement, the strength will reduce only, not increase. Please understand. Then another point is thermal cracks. Thermal cracks. Now, this is very hot. The climate is very hot in Kerala also. And in our code, the code was published many years back. At that time, they have said that every building having more than 45 meters should have an expansion joint. But in many cases, the expansion joints are not properly given. Expansion joints should be given when the direction of the building changes also. And the result is cracks develop at the beams, slabs, and the column beam joints. You can see at any time. I have got an experience in that. One school building constructed with 100 meters length. The design was given some years back, not now. The design was given from the design office of the chief engineer's office. Design was not the chief engineer office. And it was 100 meters was constructed without any joint. At that time, our expansion joint limit was 30 meters only. So definitely the building cracked. The building cracked. So many cracks appeared in the slab, beam, and wall. Almost so many walls are cracked due to the movement of the slab and beams. So, and the columns are also cracked. So how we solve the issue is we have cut the building into three and given additional support and some technical things have been done and made the building strong. Even now the building is there. That is another thing. The thermal crack is a very important thing. The expansion, every building we should give expansion joint in every 45 meters. You need not go to 45 meters. Recently, our temperature has increased by 2 or 3 degrees. So my preference is 30 to 40 meters, more than that. So that will be the best proportion, I think. Then another thing is that cracks due to excessive loading. We may design a building for residents or a college or a commercial building, and we may take the loading as per IS 875. But the people after the construction use it for some other purpose. I have got an experience in that also. I have designed a building, 3-story building for a B.Ed college in Ernakulam district. And this particular college was later converted into the main building of an engineering college. The engineering college is still there. And of course, when there is an excess, we give only 150 kilogram per m square of live load for the roof slab. And that was only given. And this gentleman, first of all, done the roofing of the building to avoid from the heat and leaching of the slab, etc. They may have given it. And later, they covered it and made it the library. What has happened? One day, the chairman called me, sir, our beams are, and under the one of the classroom, under the slab, civil engineering department is also there. I think one of the faculty member pointed out this first, and many cracks have developed in the beams and slabs because of this, they have changed the design. They have used the building, the rooftop, they have used for library. Means the loading condition has changed. So the overloading of the slab has created these cracks. So thus such cracks are also often seen. We design the building and the people use for their purpose. We design the building for 3 stories, and some of the people use it for make it as 5 stories, 4 story first, and another story they will make without our permission because they have got the drawings with them. I have seen many times this thing, especially in education building, private education building. This is a practice many times, many places. Then another type of crack is the settlement cracks. Settlement cracks means the foundation, if the soil is not proper, if it is not, the bearing capacity is poor, if it is not considered properly, the settlement will occur and there will be cracks on the building. And that is, and another thing is for the structure itself, if the compaction is not proper, if the reinforcement is congested, in many cases, we can see that as code permits 6% reinforcement in the column. So if you give more than 4%, the concrete will not enter into the column and fill it because of the congestion of the reinforcement. So my advice is, please don't go to the codal provision of 6%. You stop it by 3.5%. I think 3.5 to 4% may be the best proportion. You cannot go to more than 4%. Is very difficult. It will not be, there will be very high congestion and the concrete will not reach all the places of the column, and the honeycombing and segregation will be definitely there. And the strength of the column will be is reduced and cracks may appear. Then about the structural cracks. Structural cracks means cracks in the structure, beam, column, and the slabs, etc. And I have already told about the thermal expansion and cracks developed and foundation failure. And in many cases, due to the poor design also, and many people even now are reluctant to approach the structural engineers because they have to pay a little money to the structural engineer. They themselves do designs. They may have seen some designs and copy it. May not be the span may be different, the loading may be different, and the condition entirely will be different. But they are not considering that they are using it, and poor designing and poor detailing also is one of the another reason for the failure, the cracks developing, especially in the cantilever slabs, especially the sunshade. Many times I have seen that the reinforcement is placed either at the middle or at the bottom itself. Then why they stand? Some of them still stand because no load is coming there, and they are giving more reinforcement. Because of that, maybe it may be standing. So the correct position of the reinforcement is to be placed. The cantilever slabs and beams reinforcement shall be at the proper place, and proper detailing shall be there, or else the cracks will develop. And some people take the formwork for speedy construction. They take the formwork early, and that is also lead to cracking of the about the overloading. I've already told you. Another type of cracking is the corrosion cracking. Corrosion cracking. The water, if the water enters into the concrete through the concrete to the reinforcement side, it will definitely start corroding. Once it starts corroding, it will expand. It will expand, and cracks will develop on the surface. And we can see that at many places, the binding wire is the villain in that. The binding wires are projecting out of the concrete. I have seen many sites that the binding wire, they will tie it, and the net will be projecting out of the concrete after the concrete is completed. This binding wire will corrode easily, and through that gap, water will enter and start corroding the main reinforcement or the stirrup, etc. It will not, the danger will not happen immediately because, as you know, a 6 mm bar to corrode fully will take so many years. Immediately the result will not be seen, but after 10 or 15 years, the cracks will start because of the corrosion or the reinforcement. So we should avoid the concrete shall be watertight. So the concreting, one thing I have seen nowadays that we don't get sufficient people to supervise work who knows the work. Many do not know what is water cement torch, the importance of water cement ratio. Many do not know what is the importance of curing. I have seen a curing of columns in the hot climate. When supervising people reach there, the local supervisor will start pouring water or ask the labor to pour water over the column. That is not the alternate wetting and drying of a column will reduce the strength. So it should be wet always. So that is also another reason for the this one, and it will it will lead to the cracks in the concrete. Then another is the drying shrinkage is a long time process. After weeks and months only that cracks will come. So to reduce, almost all the cracks can be reduced to minimum. Of course, all the full cracks cannot be reduced or nullified, but you can reduce the cracks if the construction is properly supervised and well designed. And now in Kerala, I think getting a good supervisor is a very difficult task. And in our engineering colleges also, we don't give proper guidance to the civil engineering students how to construct a structure. Everybody is busy in completing the syllabus, not making them an engineer. That is the drawback in our education institution, I see. Everybody is getting ranked, interested in getting ranked and completing the syllabus. But how the students know after they're coming out? I have seen, even now I have got a lady with me who has studied MTech and taught in engineering college for 5 years. After that, she has an ambition to become a structural engineer. She has come to me. She is working now with me. Studying the structural designs with me. And I asked her, she has built a new home recently. I asked who has done the design. She said, an architect, my husband gave it to architect. Then I asked, probably you may have designed the structural part. No, sir. That also done, the architect managed to do the structural design. I think it's a real shame for our present engineers that their own work they cannot do. They depend on others. In my time, when I passed out in 1971 from engineering college, I passed out from REC Calicut. At that time, I was able to plan and design a building by myself. And that situation has changed. I don't know, the experts like Sri Mahadevan Pillai and or Dr. Biju Kumar could answer to that. And with these few words, if you take care, you can, my last word is, if you take care, you can control the cracks and make the buildings better. Okay, thank you.
Thank you, sir, for such an insightful and thought-provoking session. Next, I invite Dr. Raghukumar to our panel. Sir, please.
Respected Sri Madhavan Pillai sir, Professor Divya madam, my co-panelist and all other participants. I would like to share my screen first because I have a very small 10-slide presentation. I'm not sure whether it is being projected now. Is it visible, sir?
Yes,
No,
it is visible. You proceed with. Screen is now blank.
No, blank. Okay, sir. Let me just try. I think I have some technical issues with that. Okay, anyway, I'll be just starting, not wasting any time. Just a minute, sir. Okay.
Now it's visible, sir.
It is visible. It is visible.
Yes.
So to extend the given topic, that's cracks in concrete, I'd like to speak a few words about leakage and durability, of course, because cracks are detrimental to durability. They cause leakage also. But this topic, I'll be, my context is in the view of various codes of practice, especially IS 456 on concrete. And I assume a certain sort of ideal site conditions. Ideal in the sense it's very difficult to achieve, but still it's preferable that we should know at least what is our deviation from the ideal site condition. So to substantiate that, I'm just... So I start with two questions which come before the civil engineers. One is, what is the life of civil engineering structures? Is it 50 years, 100 years, etc.? Second question is, will the concrete permit water through it? Or simply speaking, will the concrete leak? That is the second question. Even though these questions are very simple, but it's difficult to sort of answer. I think I still have some technical issues. Please excuse me. So the first question, I'll just continue with my discussion. The first question is, what about the durability of, or what is the life of civil engineering structures? Difficult question, difficult to answer, but my answer is, civil engineering structures are eternal, enduring, and everlasting. Provided, that clause is very important, provided proper quality control is made at the time of construction, and also proper maintenance is done during its lifespan. These two things are important. So with that condition, we can make buildings which are having the eternal life. Second question is, will concrete permit water through it? The short answer is no. Because concrete is as good as igneous rocks. Because permitting water is measured by permeability. So if you compare the permeability values of concrete and igneous rocks, they are almost same, to the order of 10⁻⁷ millimeter per second. So a properly built concrete with good degree of quality control, with good maintenance, will not allow concrete through it. Now coming on to the question, a very common question for those studying BTech, especially design in the fourth semester, we come across with cracked sections for flexure design. What is the meaning of this crack? Or what is the meaning of this cracked section? Meaning is, it is only symbolic. The tensile zone of concrete is stated as cracked because we need to avoid the tension carrying tensile stress and tensile strain carrying. We need to avoid that concrete in tensile zone. That is the meaning of actually cracked section. Because if I say the concrete in tension zone is totally cracked, Then the next question comes, how this cracked concrete is holding the reinforcement with the other part of the section. So it's only conceptual, no cracks physically visible due in working stress method or in limit state of collapse. But anyway, in limit state of serviceability, the IS code, IS 456 states about crack width from 0.3 millimeter to 0.1 millimeter. 0.3 to 0.1 millimeter. Okay. But the code itself states that 0.3 to 0.1 millimeter is not causing any harm to the reinforcement because no water is reaching, or that 0.3 millimeter or 0.1 millimeter in difficult structures is not permitting water to percolate up to the level of tensile reinforcement steel or compressive reinforcement steel, so that will affect the durability. So that is the meaning of this limit state of serviceability permitting crack width. And in addition, then in IS 456, we have the concept of cover to concrete, minimum and maximum reinforcement bar percentage, minimum diameter of bar, cement content. All these things are contributing towards the durability or crack controlling. Now, the philosophy in IS 456-2000 is preventive, of course, but it's a little bit of indirect philosophy. So due to that, after around 20-25 years, this IS 456 is getting revised. Release is expected soon, and in that IS 456 new revision, excessive importance is given to durability. So in the existing IS 456-2000, we designed structures for strength and serviceability. Now 4 more parameters has been added in the new IS 456. Those are durability, robustness. Robustness means the prevention or the capacity of the building against fire and blast, not prevention, it's resistance. The 5th one is integrity. That is after partial failure of the building, what will happen? 6th one is restorability. That is after the damage, how the building can be restored. So all these 6 criteria is being introduced in the new draft of IS 456. And the thing is, all these 6 has become the responsibility of design engineer, not simply contractor or not simply owner. That is the issue here. That's why IS 456 new version is in 5th draft stage. That is not yet released yet, because practicing engineers are having some discussions, some issues. So they are still in negotiation with the BIS officials. But anyway, on the release of the the latest revision of IS 456, durability is going to become a quantifiable variable. So far, it was not like that. And durability also is going to be a performance variable of the structure. So that means we are giving due stress on achieving durable concrete. And crack is one of the critical parameters. And there are every efforts by the new code for controlling of cracks. Then, serviceability, whatever. Serviceability is basically crack control and deflection control. Basically, other items are also there. But this serviceability ensure durability. That is the main thing. Or the durability is addressing the service life as a design objective. That is in the new code. It is going to be implemented like that. And also, the durability has become a design stage accountability than construction stage responsibility. That is simply speaking, the responsibility is not simply of the contractor, You cannot blame somebody else. The designer has got the accountability. So that's also a big issue. The design firms, practicing engineers, they are facing some difficulty with the new code due to this accountability. And you can see the commercial scenario. What is the fees available as compared to an architect to the design engineer? So they are working again on that. And one more thing I just wanted to point out in this stage, IS 1893, the code for earthquake resistant design, that was released in last January, 2026 January, but it was withdrawn after 2-3 weeks. The reason is the resistance from practicing engineer. I also acknowledge their point. The point is that the new code IS 1893 is imposing higher seismic loads, which in turn, higher means too much, at least 2.5 to 3 times seismic loads than the previous code. So what will happen is our buildings become more uneconomical. Not only that, the ongoing projects like metro, bridges, other type of public buildings, all these things are going to be affected if immediately such a release of IS 1893 is made. So that resistance is also there, that negotiation is also there. It is withdrawn now, going to be released soon. So these two codes, they are very critical in the civil engineering field, IS 456 as well as IS 1893. They are being released with the due resistance from practicing engineers. So that is the scenario as of now. So what about the existing codes say about, or what about how they ensure crack control? That is also one of the main things. I have already discussed about the passive efforts by IS 456. So next issue is how we ensure leakage or water resistance for the concrete, which is basically equal to that of igneous rocks. So existing codes, we have two parameters. One is permeability of concrete. See, the permeability of concrete is tested under very stringent condition. I have the figures, but I am unable to project it. I will just tell the water pressure applied is to the tune of 5 kg per centimeter square to 15 kg per centimeter square. This means 50 meter of water column to 150 meter of water column. This much pressure is applied. And the testing is done for 100 hours. So that means such a condition is never going to happen in our RCC slabs, RCC walls, roof slab, anywhere under any severe climatic condition. So we are ensuring by passively that none of our structure is permeable. They are properly impervious or water resistance. So that is about permeability, and the value, as I have told you, it is with the order of 10 raised to -7 millimeter per second. So it's highly impervious. Second quantity is the depth of penetration of water in a typical specimen as given by IS 516. 516 is the code for testing concrete. There also, I had the figure but unable to present now. There also the depth of penetration under very high pressure. Here also the pressure is 50 meter water column depth, and the duration of test is 72 hours. Still, the permissible value of water penetration through the surface is limited to 50 mm, and the desirable value is 20 mm. So you can compare this 20 mm with the cover to the concrete. That means we are ensuring that never the surface cracks, whatever permitted by IS 456 limit state of serviceability, that is 0.3 mm or 0.1 mm, is never percolating or propagating to the reinforcement level by these two tests. So with that, we are ensuring the water tightness of concrete by these two, of course, testing or passive measure. And one more thing I would like to tell you, I have told you regarding the life of civil engineering structures. In IS 456, clause number 10.1.1 itself, it is written, the execution of work by the contractor, that is, contractor should have proper workmanship and proper care during the use of structure, including timely maintenance and repair by the owner. So this is a very important point. We often neglect this. no timely maintenance, no repair. Even if in our house also we are least bothered about that. Now, please compare the recent bridge failures all over in India. High-rise building failures, retaining wall failures, all these things, especially bridge failure, you can see if you study it in depth, the failure is mainly due to lack of maintenance. So that's very important. It is given in IS 456 itself at present. So with that, I can conclude. I had to, present a bit more, but anyway, due to this technical difficulty, I'm unable to present. So to conclude, what I'm saying is that the life of our civil engineering structures are eternal, provided it is proper quality control is maintained at the time of construction and proper maintenance also done during the service life of the structure. That is question number one. Second is concrete will not permit ingress of water because it is as good as granite type rocks if proper quality control is done and also proper maintenance is done. Thank you very much.
Thank you, sir, for your valuable information. Now, we are honored to invite Engineer Adit D to join our panel. Welcome you, sir.
Good evening, one and all. And I thank the organizers for making me a part of this technical session. I think somebody else is to speak before me. Fine. This is the right time to discuss about cracks. Why? Because the temperature has gone up like anything. In Palakkad, it has crossed 42 degrees. So concreting during this high temperature itself can create a lot of cracks. In fact, I am sitting here with half mind. Why? Because in one of my sites, concreting is going right now. It has started only at 7 o'clock. Why? Because during the daytime we cannot do the concreting because of the high temperature. And every day we are seeing in the newspapers lot of snake attacks or snakes are there here and almost all the places. I would like to compare the cracks with these snakes. Why? Because most of them are not that dangerous or non-venomous. But people are very scary about the inhabitants in the house are very scary about those snakes. Some of them are very dangerous also. So you can consider the cracks in that way. Why? Because most of the cracks are not that dangerous, but it will create a real headache to the inhabitants because you don't want those cracks to happen in your house. Whether it is a shrinkage crack or whatever little, very non-dangerous cracks, you don't want it in your house, but it is there. So I would say it is just like that snake this thing in the houses right now. In olden days, actually, I'm really because most of I'm not an academician or a structural engineer, but I'm a practicing engineer. So, but practicing with the help of these academicians as well as structural engineers. So, I thought I'll definitely speak about the practical aspects of it. Abu Bakr sir has touched most of the points. Still, if you see the olden days construction, we had given provision for all the type of, waiting period. At all the times, like foundation, after foundation, we'll be giving a waiting period for the settlement cracks to happen and disappear. Then during the for the woodwork, we'll be giving enough time for the seasoning to happen, and that should not reflect in the houses as cracks. During the brickwork, enough setting time is given. For the concreting, we'll be giving enough curing period, at least 14 days for curing. Then during the plastering, we'll be giving at least 5 to 7 days curing. And we will stop the work with the whitewashing, giving enough time for breathing of the walls, breathe out all the water, and no cracks will appear. But now what we are doing is we will be doing the putty work as well as painting right along with the construction, so that the water will ooze out and cracks will appear. And on the rooftop, we used to give feathering goes, which is not at all being done nowadays. But and we were using only lower strength cement, that is 33 grade cement, and after that 43 grade cement. But nowadays we are using, I mean, even for a small house, they would like to prefer higher strength cement, because every TV advertisement, paper advertisement, everything, they said this is the most highest strength cement. So people want to have highest grade cement, and definitely that will create a lot of cracks. And high strength cement as well as high strength concrete design mixes are now to the tune of 45 M45, M55, 50, 60, 70. And many of the sites in Kerala, we are using M70 concrete without enough preparations or enough curing process and all. So this is definitely, this will affect the quality of concrete as well as, I mean, as the Kumar sir said, the proper curing should be done on the concrete to make it waterproof or crack proof. And most of the cracks in the residential buildings as well as commercial buildings happens at the joints of two different materials, brick and concrete. That's at the time stage of where you start the brickwork from the foundation level over the plinth beam. Then at the time of the place of lintel, at the joint of brickwork and roof concrete, all these joints will crack. Definitely it will crack. You cannot avoid those cracks, but we'll have to give provision for that crack. We'll have to provide some expandable material in between concrete and brickwork, which can take care of the crack, which will use its elasticity to make it waterproof. And there are a lot of joints like parapet joint, any place. I mean, column beam joint, not the column beam joint, at the joint where the brickwork touches columns as well as beams. All these places, there are chances of cracks. So moreover, PVC conduits are the main culprits nowadays, because you will be putting PVC, lot of PVC conduits on the roof, all along the roof for taking the wires, because you don't want to cut the wall, or the electricians don't want to cut the wall. So they use lot of conduits in the roof to take the cables to this side, that side and all. Finally, what happens? The bottom side of those conduits may, if it is not properly placed, there's a chance of cracks, and these cracks will definitely look like structural cracks, and people will be much worried about these cracks. And on the walls also we'll be putting PVC pipes, PVC pipes for the bathroom, as well as electrical pipes in the walls for electrical conduiting. All these places we'll have to place fiber net before plastering, so that it will take care of the crack chances. Definitely, some other places are door window corners, which I think we can avoid those problems with proper bearings and all. And the contemporary design, what we see right now, that is the box type designs and all. All these places, no projection on roof. If there is a projection on the roof, we can provide a safe cracking zone just below the roof. But when it is the roof is in flush with the brickwork, the chance of cracking is very much high, as well as the chance of leakage is also much high. And we'll have to, in earlier days, as Abu Bakr sir said, we'll be giving provision for expansion on the big buildings, even conduits, brickwork, parapet and all. But nowadays, people don't want that expansion joints to be seen. So what they do is, normally people won't give enough expansion joints, which results in which will result in cracks. Actually, I would like to recall some of the experiences what we had when we conducted, and Mahadenbala sir was there in that seminar, and many eminent structural engineers as well as practicing engineers were present in that seminar. In that seminar, one of the participants, it was for the public. One of the participants asked a question. You being the most prominent engineers in this area, can anyone assure that they will construct a house without crack and leak for me? And all of us said it is very difficult to assure. Why? Because it is not only the design part of it, the construction part, the after construction part, everything is very important in making it crack proof as well as leak proof. So we were not able to give such an assurance to that ordinary layman. And I don't know how many of you are familiar with Dr. R.P.R. sir. Dr. R.P.R. sir was there in Tiru Engineering College. He used to come for almost all the seminars. He used to say, jovial, that if you want to see different types of cracks, you come to my house. It is a monument where you can see all the types of cracks. And of course, it's a joke only, but still that's the condition. Avoiding cracks are a little difficult, but managing cracks are much easier nowadays because we have got enough materials. Actually that waterproofing as well as crack filling industry is much developed. Like earlier we used to have doctor fix it with 5 or 10 products. Now they are with more than 3,000 products for different type of waterproofing as well as treatment of cracks as well as fixing of tiles. They have got more than 3,000 products. So managing cracks are much simple nowadays. And the only one thing I can tell you is to address the crack with expertise. Never underestimate the crack. Show it to an expert and take the necessary directions, whether to ignore it, treat it, or make a major change on it. Cracks on columns and beams are to be dealt separately because most of them are structural cracks. Definitely, I think Engineer Pramod will be in a better position to give highlight on that. And most of us are not touching the cracks which is shown out there in the ground floor flooring. There are a lot of cracks on the ground floor flooring. Nowadays, it is happening because of two reasons. One is inadequate compaction of earth below the flooring, as well as now we are filling the floor with the silt which is available from the crushers. That will definitely bulk during the rainy season and can create a lot of cracks on the floor, which normally they are harmless, but it's a real eyesore to the people, to the inhabitants. And the speed of construction, it's definitely, I mean, we were also doing apartments from the builder side as well as engineer side. So we know the pressure on the builder to complete it in time. 15, 20 floors are done in 2 years' time. So just after the casting of the slab, you will have to start the column work for the next floor. And once the floor is casted, you have to start the brickwork as well as plastering. Everything will follow one by one. So naturally, there is a lack of curing unless and until the builder as well as the engineer takes special care on the curing. Curing is as or more important than the cement used in that concrete or plastering mix. You have to give enough curing for that this thing. So naturally, we will have to take care of the curing also. And with the, I mean, the Graduates Association of Civil Engineers, Palakkad, has done a very detailed study on that the subject of cracks, and Engineer Pramod has done an extensive study on that thing, and has published a 80 pages note on that, which is available as PDF with the Gray Center of Palakkad. So if anybody is interested, definitely we can share that note to you all of you. And thank you all for hearing me. And if you have got any questions, definitely I am there to answer. Thank you very much.
Thank you, sir, for sharing your knowledge with us. Next, we invite Dr. Nisha AS to be a part of our panel.
Yeah, thank you. So I'll share my screen. Please do let me know if that is visible. Okay.
Yeah, it is visible. Please proceed.
Yeah, thank you, sir. So I was listening to the expert members over here talking about the cracks in concrete, and I just want to take my session in a different perspective. From a structural health monitoring point of view, how do you consider cracks in concrete? Now, so I think I'm in the next slide. Hope you can see the next slide. Yeah. So as we know, health monitoring, just like how we have a human health monitoring, so is the structural health monitoring. Just like how a human body is diagnosed with proper medical facilities and then taking the required treatment at the right time and maintaining the proper health. So is the case of the structure with the same philosophy, where if already the structure has come into existence, how do you ensure whether it is in a perfect condition or what is the current condition, or how do you assess the current condition of that structure? And same way, just like how we take MRI and other X-ray and other medical tests, here also, as we know, that you put some sensors and try to capture the exact measurements of what is happening with that structure. And with that information of the measurements from the various types of the sensors, you try to understand or diagnose the kind of the behavior of the structure, and then you act. And that ultimately helps us to ensure the safety and the longevity of the structure. And this is what about the structural health monitoring in nutshell, as we all know. So it's the main aim is the more early you detect, you can have a proper decision. The timely intervention will help you to maintain the stability and the durability of the structure. Now, what cracks has got to do with the structural health monitoring perspective? Now here, as most of our panelists were rightly pointing out, the kind of cracks which we usually see Some of the predominant one includes the flexural shear, shrinkage, or thermal cracks and settlement cracks. All these cracks, as we know, that can cause a various change in the structural properties. With the crack initiation or with the growth of the crack, there could be a degradation with respect to the stiffness of the structure. Even that can change the dynamic properties like the natural frequency, mode shape, damping, and other characteristics, which ultimately gives you an idea regarding the strength, serviceability, durability, and safety aspects. So from the structural health monitoring point of view, I would say that cracks, which are some kind of measurable signals, they are not just defects. They are data. If you put it in that way, they helps us to have an early detection, monitor in a smart way, and to take a timely action. So knowing about cracks in health monitoring helps us to understand the current health of the structure. With that, you can predict the future behavior and you can ensure the safety. So here that has got a positive aspect as well. Once the structure has come into existence, how do you detect what is happening inside the structure? So one way is through the cracks, which of course are the different ways. Now, in that sense, cracks provide vital information regarding the early signs of distress and if there is a potential for a progressive collapse, and if it affects the durability or water tightness of the structure. And with an early detection of all these, you can, of course, reduce the maintenance cost and prevent the major disasters. So that shows the relevance of knowing about the theory or knowing about the behavior of the cracks in health monitoring. And of course, we know that health monitoring techniques are, there are wide classification based on the kind of principle involved in it, based on the type of the measurements that you take, based on what kind of responses that you capture from from a structure. Based on that, of course, there are various structural health monitoring techniques. Of course, visual inspection is the one which is most predominantly used, and that we know that depends on how much expertise that particular engineer has in identifying or in understanding the behavior of the structure, because there we make use of our sense organs, like we see, we feel the structure by our touch, and even using some tamping methods, we can get to know the sound. So all these things are a kind of visual inspection where you get to know and you interpret all these results with the expertise of the engineer. But then when you move to the sensing techniques, all these you can measure using sensors, right? We can have different types of sensors which can measure the strains or accelerations or extensometers. We can measure the transducer. We can measure the LVDT story drift using LVDT's displacement. Different types of measurements can be taken by various other methods as well. But then you might be wondering, okay, if then why do we need to have a practicing engineer when we can capture all these responses or all these data from the structure? So here lies the relevance, because computer has got a brain which can only sense these responses, but it cannot interpret what can be taken from these measurements, right? So based on that, even though the sensor technology has advanced, the sensing has advanced, everything has advanced, we cannot simply rely on these sensing technologies in order to understand the behavior of the crack. Where lies the relevance of the expertise, as what you can see among ourselves, the various panelists, what they were talking about from their experience, and that cannot be replaced by any of the sensing technologies. So apart from the visual inspection methods, we come across with the vibration-based methods where you measure the natural frequency, mode shapes, and things like that. We have strain deformation-based methods. We have acoustic emission methods where you make use of the acoustic waves in order to, that will be made to propagate and try to identify or detect the kind of the crack. Then we have the ultrasonic methods, electromagnetic methods, fiber optic based methods, and then now we are in a era of using digital twin, artificial intelligence or machine learning based damage techniques and things like that, which are the current scenario. So what I would say is that all these different structural health monitoring techniques, they complement each other. But however, which one do you need to select? That depends truly on, one is what kind of structure that you're going to do the health monitoring. Second is what kind of cracks do you expect? And what are the failure modes? And of course, your accessibility to take the measurements, and of course, the budget. So with this structural health monitoring techniques, I just want to take you to the slide where I've just, from the literatures, what has been available, I've just tried to put it in a single slide where you can see on the left side are the various structural health monitoring methods. And one thing which I told is all these methods, how would you choose which one is for what? Of course, there is no single method or there is no single best method. The suitability definitely depends on what kind of structure, what are the crack characteristics, and what are your goals. Whether you need to detect the micro cracks or whether you need to detect the major cracks, what are the things, what is your goal? So a hybrid approach will always provide the most reliable and meaningful results. And here on the left side, we are having the different structural health monitoring techniques which are available. And on the top, some of the major structures which will be subjected to the health monitoring with bridges, high-rise buildings, industrial structures, dams, and tunnels. And then the suitability of each of these health monitoring techniques for a particular structure has been put here or has been tabulated, showing the kind of suitability where the green dot indicates it is highly suitable. Yellow indicates it is moderately suitable, and red indicates it is less suitable. For example, if you want to take an early crack detection in bridges, then acoustic emission is not that suitable. But if you want to have a local strain in the kind of the bridges, if you're interested in determining that, then maybe a strain based health monitoring technique might be more suitable. So in that sense, with the literature or with the current state of art, what has been published, just try to give a kind of a suitability in choosing the structural health monitoring technique, depending on the type of the structure. So here, one thing is, of course, the technique depends on what structure you need to monitor. And the second thing is what kind of cracks that you want to monitor, or what are the cracks that are prominent in the kind of the structure or in the structural elements which you are going to do the condition assessment. So again, the same way, on the left side, we have the different structural health monitoring methods. And here, instead of structure, on the top, I've just put the different types of the cracks, which we usually see in a structure, with the flexural cracks, shear cracks, shrinkage cracks, fatigue cracks, thermal, and the bond or debonding cracks. Again, for a particular type of the crack, which method is most suitable? That is, the same way it has been plotted here, but the suitability rating is also given. So different SHM methods are sensitive to different crack type. For example, a proper, if a particular structure is subjected to some of the predominant cracks like flexural crack, we may not be able to apply some of the structural health monitoring methods. So how do you choose that? For that, you need to have an idea which method is sensitive to which type of crack. So a proper match between the method, crack characteristics, and structure ensures reliable detection and accurate assessment and a timely intervention, which in turn will guarantee the lifetime of the structure. So these two factors has been put forth in a single platform, where based on what kind of structure, what kind of the crack, what is the suitable method that can be adopted. This is something which has been developed as a kind of, what do you say, kind of a selection criteria. And of course, you need to have you can have more than one methods also for the health monitoring of the same structure, because you might be interested in determining more than one crack. So it is not that a structure is monitored only by one particular method. You can have a combination, but how to select them, how to select them, in that the type of the crack do play a vital role. That's what I'm trying to say. So different SHM methods can be selected based on the crack characteristics, and that will ensure to what extent your structure is correctly monitored, or whether you have assessed the assessment, whether you've made a correct assessment of the structure, and things like that. So in that way, I would consider cracks in a positive sense, like they are indicators in structural health monitoring. Right from observation to insight and from insight to safety, they are not defects. I would say that they are data. They helps us to understand, predict, and protect structures. So if you select the right structural health monitoring method for the right crack in the right structure, we can always move from a reactive repair to a proactive care. So this is what I would like to highlight from the structural health monitoring point of view. Whenever you want to assess a structure, the only way out is some kind of cracks on the structure, which will give you a warning signal, which will help you to understand, which will help you to interpret and to take steps forward. So that's all. It's a very I just want to keep it very minimalistic. So with that, let me end. So when we start measuring cracks, we stop reacting to damage and we start managing structures intelligently. Yeah, thank you. That's all from my side.
Thank you, ma'am, for your thought-provoking session. We invite Dr. Adira Gopinath to our panel.
I hope I'm audible.
Yes, you're audible.
Respected Sri Mahadev, I would like to say thank you for inviting me to the forum. I really appreciate the opportunity, not only to talk, but also to listen to all these experts in the field. It's really quite an interesting session. Abu Bakr sir, and also dear Professor Raghu sir, and all other respected co-panelists and audience, good evening. I'm also very happy on a personal front as well, because I'm really honored to be sharing this platform with Raghu sir. He might not remember me, but I was one of his students at JC Calicut, and he was my most favorite professor ever. I've continued my academic journey for so many years after that, but I would still be remiss if I didn't say that I have never learned anything from any other teacher as much as I've learned from him. I've looked up so much to him. And that said, I'm not really a structural engineer, so I'm not really going to directly talk about the structural aspects of concrete cracks. We have a lot of other panelists who have done exactly that and who will be doing exactly that. So I would take a little bit of a detour in that direction and say, whenever we say cracks, it's not really the structural cracks in the most common settings of residences. We are not really talking about structural cracks. It's mostly that most of the times it's a visible cracks that the common people would ask is, why is this so? As soon as you're done with a civil engineering degree, you get loaded with these kinds of questions. In my house, on this particular corner, I have these many cracks. Why is it happening? But almost always, they would be referring to plaster cracks, not really the structural cracks. It could also be a reflection of the structural cracks, but that's not what I am going to be discussing on this particular forum. I work a lot on concrete, not on the structural aspects of concrete, but as concrete as a material system, experimenting with alternative binders and other kinds of alternative construction materials. So whenever you get asked, why is this crack happening to a surface rendering, and I don't always have, and most of the times I don't have encouraging news for the people who are asking me that, because the advice you could probably give them would be to reseal the cracks and then continue as business as usual. But you would know that it is bound to come back. But there is nothing much you can do apart from stripping it all over and then redoing it from the beginning, because the issue is not really just the plaster, it's the compatibility between different kinds of materials. So as I would take from whatever all the other experts in the field have talked and said about, we have had experts say that concrete is a very water resisting material. It's a very impermeable material, and it is not just concrete. Mortar is also a very impermeable material, just that it does not have the coarse aggregate in its system. So when we use this, and I'm not talking about high-rise structures, I'm talking about small residences, almost all of our houses, where we have load-bearing structures, which are most of the times constructed with laterite stones or bricks, mud bricks, or something like that, something on that line of materials. Almost all of them are porous, and they do allow for water and water vapor to diffuse through. So, why I am talking about water vapor and water at this point is because those are material system which would allow for a certain level of water and water vapor to diffuse through these pores, while we are essentially sealing off that kind of capacity of water diffusion through these pores when we are sealing these material or wall systems with dense cement mortar plasters. Not that cement mortar plasters in itself is bad, but if you do seal off a system that can diffuse water through its pores, using a very impermeable materials, you're bound to have material incompatibility and pooling of water in between these two interfaces, and then cracking and spalling and stripping and whatnot. Now, why we use mortars, cement mortars especially, because we know that it's a very good system. It's very impermeable to water, so it would resist water ingress from the outside, and we don't want damp walls. That's why we seal it off with cement mortar plasters or cement plasters. But do we really get damp-free walls? No, we don't. We most of the times we don't, especially when the climate is humid. When the monsoon hits, we do have ingress of water through different, either from the foundation level up, and then it comes out. Your plaster looks as if it's ridden with fungus. Why this is happening? Because we only protected our walls from the outside water ingress. We didn't do so much to protect it from the ingress or the water ingress that would seep up or creep up from the foundation level, unless you have done, some kind of prevention for water penetration using some sheets or beams of concrete or something like that. But most of the times that does not happen in house construction, at least. And this water would come up through the walls, and then it has nowhere to go. If it was left exposed, not that I would recommend exposing the walls, if it was left exposed, the water would have breathed through these walls and then evaporated off eventually, without causing any kind of stripping or stripping off of the outside plaster. But we don't allow that to happen. We seal it up completely with something that is as impermeable as igneous rocks, as I was saying, right? So we allow for that pooling of water to happen. We allow for that stripping of the plaster to happen. So what essentially can we do to not let that happen? Would of course be to seal off the foundations, and then if it happens from on top, from the roof, to seal that off too. And the second thing would be to use plasters that are compatible and that can also that can also behave very much like the way the walls do breathe. So breathability is a measure that we don't give enough thought to whenever we are constructing houses or whenever we are constructing structures. The breathability of render materials is something that we have to look at. And it's something that now people have started looking at because of a lot of reasons, not just because of structural reasons like the stripping off of plaster, but also because of the moisture buffering action and the related indoor heat stresses, related reduction in the indoor heat stresses. Now, this is a completely different topic. I wouldn't go too much into depth there, but breathability is nothing but the capacity of a material to allow the water vapor to diffuse through its pores from inside to outside. So if you have a breathable wall system, like bricks, clay-fired bricks, or fire clay bricks or like laterite stones, you essentially should be having a compatible breathable plaster. Now, we used to have compatible breathable plasters before, which were lime renders or mud lime renders or things like that, which would have a really high moisture buffering value. That means it is able to regulate the moisture in such a level that it will be able to diffuse the water vapor from the outside to inside and from inside to outside, depending on where the relative humidity is higher. So this in one way is something we call as moisture regulation. So I will not, I don't want to go off on a tangent, dealing too much or delving too much into the depth of why this happens and how this happens and how we measure. But there are standardized codes for measuring the moisture buffer value of materials uh, developed by the scientists in the Norwegian countries, and then now is adapted to ASTM codes. But it's not really been adapted to the Indian context, which is something that we're trying to do with our research here. But it is something that is all the more, I mean, it's of so much more importance in our context, especially in the context of high heat stresses and the high thermal gradient that we now have. Because apart from the moisture regulation, these plasters can also regulate heat stresses because it can regulate the relative humidity of the indoor environment that we have. So now I started from cracks, and then I would like to go back to speaking about cracks in the plasters. So one thing that we would be able to do to regulate the cracks in the plaster on the render or in render systems would be to change the material system that we use from the dense impermeable cement plasters to or gypsum plasters to other kinds of plasters such as lime plasters or mud lime plasters. They do come with their own sets of issues, which is not having standardized methods of work or standardized binders or standardized binders that are available. That is one part also that we are working on. And the second thing would be to effectively protect your walls, not only from the inside and the outside, but also from the top and bottom, so that there is no seepage of water in any way. But if there is seepage of water in one way, it needs to go out some other way. If not, it will pool in between and then cause cracks for sure. So that said, I would like to stop here. Thank you once again for all of you for inviting me here. It was a really nice session.
Thank you, ma'am, for your valuable session. Finally, I invite Engineer K.O. Pramod to join our panel.
Am I audible?
Yes, you are audible. Audible.
Okay.
Please proceed.
Okay. I know we are late running. Anyway, in next 10 minutes, I wish to offer a fractional framework.
Can you be a bit more louder? Maybe
Yeah.
the mic is a bit away. You can be a bit more louder. Okay.
Okay. In the next 10 minutes, I wish to offer a practitioner's framework. Anyway, subject cracks in concrete is very interesting, enthusiastic, and evergreen topic, but nightmare for a practicing professional. Anyway, 4 distinct sources of cracking are cracking in concrete. 2Ds and 3Cs. 2Ds means designs and design deficiency and the detailing issues. Then construction issues and climatic factors. First, in the start of the meeting, Mahadev sir was pointing out why not cracks, why not rehabilitation buildings cracks. Anyways, then I have to start from the bottom. That means climatic issues. Abu Bakr sir was telling in his session about drying shrinkage. Reduction in volume as free water evaporates from the hardened concrete. Volume reduction restraints by other base, by reinforcement, etc. This restraint converts into volumetric change to tensile stress. When this tensile stress exceeds tensile strength of concrete, crack occurs. Even in, I think in why not, in site it is used M25, then crack will occur 2 to 3 when the tensile strength exceeds 2 to 3 Newton per mm square. Actually, high water cement ratio or low humidity or high temperature and this post monsoon season may cause e-disc drying shrinkage cracks. Other issues like because of the this one climatic issues or environmental issues. I wish to say more than these climatic issues. This is exposure conditions as in our IS 456. Drying shrinkage is most common environmental crack. Other cracks are climatic issues, thermal cracking from heat of hydration and ambient cycles. While we are doing mass concrete, just like rock foundations, retaining walls, interior hits significantly due to heat of hydration, while the surface of remains relatively cool. This temperature differential may, which can exceed 20 to 25 degrees Celsius, creates tensile stress in the surface. IS 456 and BS European Code 1993-3 both address this. Mitigation involves fly ash replacement, but in our scenario, we in our situations in our state, we won't much encourage fly ash replacement, but it is essential for reducing thermal cracks for mass concreting. Then other is environmental factors, corrosion induced cracking. This is the durability crisis because Kerala is the coastal zones nearly 60 kilometers away from the seashore, sea shore. Chloride-induced corrosion and reinforcement is primarily long-term cracking mechanism. Chloride ion penetrates through the concrete cover and indicates displacing of the steel and cause rust. Rust 3 or to 4 times the volume of the original steel. This expansive pressure splits the cover concrete and characteristic longitudinal crack parallel to the bar. This is also termed as our exposure condition issues. Alkali silica reactions and chemical attack. Certain reactive silica aggregates, some lateral varieties and certain reverse sands react with alkali from cement to form gel and absorb water to expand, producing the well-known map of cracking or crashing pattern of the concrete surfaces. Similarly, sulfate attack and chemically aggressive soils, marine clays reclaim the land, disseminate the cement paste and producing expansion cracks and the characteristic white effervescence. Proper material testing before mixed design is preventive step. Then I wish to talk about issues. Actually, in not only in Kerala but also every state uses most modern softwares like ETABS and the STAD, etc. While using these softwares, we have to familiar with the usage of these softwares. I wish to speak about while using ETABS. I am talking about torsional cracks. If you are not familiar with this, while you are applying compatibility torsion in ETABS, we will apply 0.01 torsional modification factor. Then it will cause cracking this one slabs because it will be transferred to, while the torsion will be spandrel beams, torsion will be transferred to slabs, then slabs will crack. This happens in ETABS. While using ETABS, we have to be very careful about the spandrel beams and while using the secondary beams, joints and primary beams. Second thing is the detailing issues. Detailing issues mainly occurs while detailers, that means may not be engineer, they will be treated by the diploma holders. They will make bars, approximately reinforcement number of bars. while detailing, then difference between two bars exceeds the limits as in table 18 of 456, there may be crack. We should be very careful about detailing and other issues. The other thing is, while detailing, not most probably the designers won't detail about the building sections. This also makes cracks. That means hanger rods will not be placed and hanger bars will not be placed. Then these are also makes cracks and all. 13 construction issues. While construction issues over vibrating and over vibrating and the resulted segregations, it will cause the crack later. Then other sources are while concreting while construction are honeycombing. While removing, while placing the shuttering and all, normally people will not make water resistant. Will not make water resistant. It will make honeycombing, and 5% honeycombing will make 20% strength reduction, and this may lead to cracks. Bleeding and plastic shrinkage cracking. Bleeding occurs when excess water migrates to the concrete surface and leaving water-rich weak topper. If this surface dries rapidly, as it does in our Kerala sun or under wind, before concreting has gained any strength, plastic shrinkage cracks appear. These are shallow cracks, often a map pattern, and while they may not be structurally critical, they become pathways and moisture and chloride ingress, triggering to long-term durability failures. Actually, Ajit sir was comparing cracks as snakes. I will compare cracks as virus because the mutation of non-structural crack to structural cracks is very much possible. Premature form of stripping and loading. The formwork removed before concreting. Concrete reaches adequate 70% of characteristic strength as its practical benchmark. Structural load causes cracking in an insufficiently cured surface. This compounded when construction loads, stacked materials, equipment are placed or recently cast slabs. These early age cracks, if present under neutral axis, can grow progressively with service loads. Pure curing and silent destroyer are the other construction issue. Concrete gains strength through hydration, a chemical process that requires moisture, inadequate curing, especially in that 7 days strength hydration, reduces the surface strength and creates steep moisture gradient and between surface and the core. This gradient induces shrinkage cracks at the surface that can penetrate deep if restraint is present as per IS 456 clause 3 mandates. A minimum 7 days moist curing for OPC and 14 days for blended cements in hot dry weather. For slabs, for beams less than 6 meters, it is around 14 days, and more than 6 meters around 21 days. And if you are using PPC, we have to extend 7 days. Regarding the, I need to make a mark on design issues while flexural cracking under design and wrong load assumptions, because here, as Abubakar sir mentioned, here happens special residential will be maybe made to commercial buildings, and the commercial building will be made to storage buildings. That happens everywhere in Kerala. It may result in flexural cracking from under design or wrong load assumptions. Punching shear and flat slab design omissions. Most probably for reducing the height of the height reduction in because of the beam. Most probably in Kerala, it is a practice to go for flat slabs. In flat slab without drop panels, punching shear around columns in critical design check. An inadequate depth or missing shear reinforcement leads to characteristic star pattern cracking around from column heads. And extreme cases, a characteristic punching shear failure. This is a pure design error. No amount of good construction stays structurally under design sections. The most other reasons for crack is different settlement of geotechnical structural interface. When a designer assumes a uniform bearing capacity under combined or strip footing without proper soil investigation, visual segment of supports causes diagonal cracks at 45 degree and typically in the lower panel of the wall or at re-entrance corners and L or C-shaped plan. The root cause is design process, not the material. Regarding the detailing deficiencies, inadequate development line. We know now we are using FE550 bars. The development length required is that is very much for M20 and M25 concrete. For M20 concrete is 63 for flexible members, 63 diameter bar, and M25 concrete is 53 diameter bar. Either we have to increase the beam depth or our flexible member depth. Otherwise, we have to go for the higher mixes. That means M30 and all. Now PWD, etc., and government buildings are all preferring more strength such as M30, M35 and all. Because of this, we are using FE550 bars nowadays. That means it attracts more development length and anchorage length and lap length. Most of the, we can see in residential buildings, most of the lintels are having horizontal cracks because of the slipping of the bar, because lack of bonding stuff, because of lack of anchorages nowadays. Excessive bar breaking, as I have told earlier, most of the cracks in Kerala scenario is in lintel and beam and all. For the placing easiness, they will be providing 2 bars only at the bottom. Because of distance between bar exceeds, there will be crack. There will be a launchable crack. Other thing is the detailing of the stirrups. Nowadays, designers are not providing the stirrups patches. That means if you are in spandrel beams and where torsion is there in the primary beam, we have to go for closed stirrups. Otherwise, the slippage of the stirrups may occur at the ultimate situation, and not only the shear crack occurs, but also U-shaped cracks occurs every time. Absence of skin reinforcement and secondary reinforcement. As a physics says, when you are considering or the torsion is even if it's an imaginary force in our code, in our code there is a problem in detailing in IS 456. There is a problem in clause 41 because in compatible torsion, IS code recommends we have to use literature than referring our code. That means percentage of the torsion to be applied is to be taken from latest literature. And another clause is there. While we are using for torsion, we have to not only we have to design the combative torsion design, but also we have to provide skin reinforcement. In deep weavings and where torsion applies, the web exceeding 75 meter, that means deep weaves. And where combative torsion is considered, IS 456 mandates skin reinforcement on the side face. Without it, diagonal face cracks, not structural but visually alarming, appear along with the web. Similarly, absence of temperature and shrinkage steel in slabs, as mandated by minimum steel portions, allows controlled thermal shrinkage crack occurs. In my observations, I have told 4 sorts of cracks. That means design, detailing, construction, and climate. That means exposure conditions. My observations, cracks occur not by one reason only. Either two or multiple reasons for a crack. Crack will not occur due to one reason only. So we have to be careful about all the design, detailing, and construction, and our climatic segments. Our codes, most of the points code our present IS 456 is covered. But our code is also going to review it. Already it is available in net. Our code will be revised by the July 456. Anyway, before closing, I wish to place a prevention mantra. That means cracks in concrete rarely have single cause. They are the cumulative result of decisions made or not made at the design table, on the drawing board, at the batching plants, and under the sun. Thank you.
Thank you, sir, for such an insightful session. Now, we open the floor for questions from the audience. Participants are requested to post their question in the chat box. So, participants, please take your opportunity.
I think those participants who want to ask directly can unmute and ask also, in addition to posting. Both can be entertained. Either you can ask directly or you can post in the chat box. And panelists are here. So based on the topic, one of them will answer. And if there is no answer coming from inside, I'll also answer. Okay. You can either ask or you can post in the chat box.
Good evening.
Good evening.
My question is to Mr. Pramod. Pramod, you have been talking about a couple of softwares, like I think one software, eTabs. Is it eTabs or eTab? eTab.
eTab.
Or eTab.
eTab.
TAP, you mean?
No.
ETABS.
BS. Okay, fine. Because the other one is, of course, we do use both the softwares, especially for the other one is basically an electrical designs platform, which we use it for power systems. And the one, of course, we are using it. Okay, fine, thank you. And another one is, of course, it's fine to have a postmortem. Like, what exactly is the, see, at this point of time, what we are facing in Kerala is that the temperature gradient is between 20 degree to 50. So a delta that what we are facing from one climate to another climate, for one season to another season is about 30 degree, which, so what exactly is the curative mechanism that we can have it now as far as an end user is concerned? What exactly is our takeaway from the whole episode? How can
actually, are you telling about the Kerala conditions or any
yes,
other?
Of course,
because
we have been focusing. Yeah, of course, yes, please. Yeah.
Actually, in Kerala situations, the temperature gradient is mostly 15 only. That means 28 to 43. That's the conditions. Anyway, in design stage, we can consider that temperature gradient. There is provision for considering temperature gradient in softwares and manually also. We can consider in design. We can temperature reinforcement we can provide in roads and all. We are providing temperature reinforcement. We can consider the temperature variations in design.
No, Mr. Pramod, I'm not really convinced with the answer. Sorry to extend it.
That means temperature, there is design for temperature deviation. Yeah.
Would you mind? Of course, design state is fine, but there is again a gap between cup and lip. See, the design, the thing in paper, and the moment it comes into the reality, it has got a lot of other hands to be in between, is it not? So you'll be having a contractor.
Actually, exposure conditions. We are controlling by exposure conditions. We got extremely that condition. There is that conditions. We will increase the our grade of concrete. That means we will go for M30 and all. For the this one, then our tensile strength of the concrete will increase up to 3 to 4. That way we are controlling that.
Okay. Thank you.
And I'm interrupting for a moment. We will be issuing certificates to all the participants, those who are filling the form given in the chat box. So while discussion is going on, you can fill that Google form given in the chat box. Now proceed. Now others can ask, please.
My name is Rahul. Actually, I'm working as a quality manager, one of the construction company in Thrissur. So I have a scenario in one of my projects that cracks are observed in very early stage. That means after pouring 3 days, that cracks are observed, and that cracks are throughout the slab thickness, and that cracks are visible perpendicular to the beam. So as we have started the early curing and wrapping the plastic sheet, and continuously we have done the 14 days curing, and after 21 days only we are disinfected and vapor it. So after all of this done, that cracks are observed very unhealthy. So what is the reason for that crack, or which type of cracks that is a flexible cracks or any shingle crack of like that? So that concrete grade is M60.
It was not clear, hearable, audible. Will you please
Hello, Pramod sir?
Yeah. Will you please repeat once more, or it is audible because it is somewhat this one.
Sir, this is my current scenario is cracks observed in a very early stage. That means 3 days after 3 days of pouring, the cracks are observed. And after the deshuttering, we are observed that crack throughout the thickness of the slab. The thickness of the slab is around 300 mm. And that cracks are observed perpendicular to beam, and the cracks are crossing to the beam also.
At only one side, only one crack. Only one crack.
Not only one crack. And the one panel is like that 8 meter by 8 meter, like that one panel is there. That flat slab only. So that crack, 1 or 2 cracks is there. L-third also one crack is there. Middle of the beam also one crack is there. Middle of the panel also one crack is there. And
in the same line, in same line.
On the straight line.
In straight line. I think that's a drying shrinkage cracks. That means your drying shrinkage cracks. Check your. Have you used the RMC, ready mix concrete?
Yeah, ready mix concrete only. So M60 only.
Yeah, have you checked the jelly size? 20 mm, 12 mm is there. 12 mm and 6 mm is more.
No, so 12 mm is there, 20 mm is there, 70-30 proportion is there. 6 mm is not there. It's we are using the microfine also. Microfine and
what is the exposure you have casted this day for summer season?
No, it's mass concrete. It's around 1000 m3. It's done day, night and that.
Day and night. Time when you have poured that time?
Yeah, we have started morning 5 o'clock and
which month?
This March, February month.
Pardon?
February month.
February month. Okay. This the drying shrinkage cracks.
This is great. So not worried about. Don't worry about.
Actually, I told you, virus will get the mutation. Before that, you have to treat the crack. That means this will be destroyed by environmental actions. So you have to fill the crack with epoxy and all. We have to treat efficiently. Am I right, sir? Babu Bakar, sir? Am I right?
See, hearing his talk, I doubt something else because he has told that it is 300 mm thick slab. That means it's a flat slab of high span. Maybe span is around 8 to 10 meters. So I doubt improper reinforcement positioning also may be a reason. It may not be due to material alone. I have seen this in flat slabs some places. Flat slab
If
design
you
is
told-
not properly done. You know, the flat slab has got different areas where the meshes have to be arranged accordingly. And if the design considerations are not properly followed, structural cracks can come in flat slab very commonly because the span is very high. It's not like a 300 mm thick slab is a very thick slab. Flat slab, we use that. So I doubt that also. It may not be due to just material alone. So only if we see the design, a correct opinion can be given in that. One or two places I have seen on flat slab such cracks. Because you know the flat slab regions, the negative and positive moments are changing in between. In the flat slab, just like the continuous beams, it is happening. So that possibility is there. So we cannot, and moreover, he's saying that even 20 mm reinforcement is used. 20 mm reinforcement is
he's telling the crack is top to bottom. That means bottom to top it is there. That means
yes. So structural crack possibility is there. So only after seeing the design it can be confirmed.
Rahul, what's the span?
It's a span nearly 8 meter by 8 meter, sir.
8 meter by 8 meter. Anyway.
It's a
Reinforcement
flat
20
slab
mm.
only. It's designed as a flat down only. But sir is
You are telling
telling
about the beams, no?
in between beam is there. This panel and that panel is open only. It is beam to beam panel is telling that.
Flat slab without drop. Flat slab without drop.
Without drop. Only this beam only is there.
Okay.
Not
And
capital
a crack came in the middle.
A crack is visible in the beam also.
Beam also. Beam.
Yeah.
That means in the some end you have you are telling about the flat slab with drop and without drop. 4 set beams are there.
Yeah, full set beam is not there. Some
Okay.
in between
Some-
gap is there, but sir, I am
how
not clear
deep-
with the question. Throughout the beam leakages is observing there.
Do you have a grid system or it is
It's a
totally
grid system.
supported by 8
Grid
meters
system.
beams only?
Grid system, sir.
Okay. So,
It's a driveway. It's the entire driveway is only that grid system.
so the load is quite heavy being a driveway. And the design, if it is improper, I doubt it's a design failure. Anyway, that has to be checked thoroughly.
It's a construction stage only, but after the very early stage, is crack is observed.
Yeah, that is why I told it's not a material failure. Crack would have occurred throughout the thickness. Material failure will be location-specific cracks. This is a structural crack. I hope so. Anyway, only after knowing the details of the location and loading and reinforcement, we can tell exactly. But I doubt. Mostly it will be a structural crack.
I think the negative bending moment has not been taken care of.
It is possible. That is why it said it may be possible.
It's 8 meters span. Heavy negative bending moment will come there.
And in an 8 meter span, negative bending moment may be 2 to 3 times that of the positive bending moment. So maybe their calculation would have gone wrong, or even the designer may not have been experienced. Possibilities there. That is why I told it may be structural crack. You are right, sir. It may be negative bending moment they may not have considered, or else they may not have assessed the point of contraflexion correctly. That is possible.
And for a flat slab, why should you use beams? There is no.
Some people give like that. Instead of drop and column, they give beams at specific intervals. I have seen in some basement construction like that.
It is
They
not.
give they don't want columns in between. They give heavy beams, and the beams are spaced around 6 to 10 meters.
Someone has written ഈ സിംഗിൾസ് ക്രാക്ക് ടോപ്പ് മുതൽ ബോട്ടം വരെ ഉണ്ടാവും. ഒരു ചാറ്റ് ബോക്സിൽ ഇട്ടിട്ടുണ്ടായിരുന്നു. സിംഗിൾസ് ക്രാക്സ് ടോപ്പ് മുതൽ ബോട്ടം വരെ ആ ക്രാക്സ് ത്രൂ ഔട്ട് ഉണ്ടാവും.
ബട്ട് അത് സ്ട്രൈറ്റ് ലൈൻ ആയിട്ട് തന്നെ ഉണ്ടാവുമോ?
സ്ട്രൈറ്റ് ലൈൻ ആയിട്ടായിരിക്കും വരിക. കാരണം എന്താ വെച്ചാല് ഇതിന്റെ കോൺട്രാക്ഷനും ഇത് സങ്കോചം വികാസവും അപ്പുറത്തുള്ള ബീമോ അല്ലെങ്കിൽ വേറെ ഏതെങ്കിലും മെറ്റീരിയൽ റീസ്ട്രെയിൻ ചെയ്യുന്നതുകൊണ്ടാണ് നടുക്കൂടെ മാത്രമേ വരുള്ളൂ. അതും ആഫ്റ്റർ 3 months, 3 മാസത്തിന് ശേഷം 3 കൊല്ലത്തിനിടയ്ക്ക് എപ്പോൾ വേണമെങ്കിലും ഡെവലപ്പ് ചെയ്യാം.
പക്ഷെ ഇത് 3 മാസത്തിലല്ല സാർ, ഇത് 3 ദിവസത്തിനുള്ളിൽ
3
വന്നിരിക്കും.
ദിവസത്തിലാണെങ്കിൽ സാറ് പറഞ്ഞ പോലെ ഡിഫറെന്റ് ഫീലർ ആവാൻ സാധ്യതയുണ്ട് കേട്ടോ.
ഓക്കെ 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 മാഡം, ഹലോ
ഹലോ,
ക്ലിയർ ആകുന്നില്ല, ഒന്നുകൂടെ പറഞ്ഞോളൂ. യു ക്യാൻ ടോക്ക് അഗൈൻ, ഇറ്റ്സ് നോട്ട് ക്ലിയർ.
അതെ സാർ, ഞാനേ വേദവ്യാസ അലുമിനിയാണ്. അപ്പോൾ കഴിഞ്ഞ ഒരു സ്ട്രക്ചറൽ എഞ്ചിനീയറിംഗ് സ്റ്റുഡൻ്റ് ആയിരുന്നു വേദവ്യാസയിൽ. കഴിഞ്ഞ 14 കൊല്ലമായിട്ട് ഒരു പ്രാക്ടീസിങ് എഞ്ചിനീയർ കൂടിയാണ്. അപ്പോൾ സൈറ്റിൽ ഇപ്പോൾ കഴിഞ്ഞ 6 കൊല്ലത്തിൽ നമ്മൾ കിഫ്ബിന്റെ 53ഓളം സ്കൂളുകൾ കംപ്ലീറ്റ് ചെയ്തിട്ടുണ്ടായിരുന്നു. അപ്പോൾ അവിടെ ഈ സ്ട്രക്ചറൽ ഇൻസ്പെക്ഷന് പോകുമ്പോൾ പല സ്ഥലത്തും ഈ ക്രാക്ക് ഡിറ്റക്ഷന്റെ ഒരു പ്രോബ്ലമാണ് മെയിനായിട്ട് നമ്മൾ ഫേസ് ചെയ്തിട്ടുണ്ടായിരുന്നു. അപ്പൊ അതിൽ നമ്മൾ ഫേസ് ചെയ്ത പല ഇതിലും എന്താ വെച്ചാൽ നമ്മൾ മനസ്സിലാക്കിയ ഒരു സംഭവം എന്താ വെച്ചാൽ, ചില ഹാളുകളിൽ ഇപ്പൊ നമ്മള് വരാന്ത ഉണ്ടാവുമല്ലോ സ്കൂളുകളിൽ കോളേജുകളിലൊക്കെ. അപ്പൊ വരാന്തന്റെ മറ്റേ ഒരു വാളിലൊക്കെ കംപ്ലീറ്റ് ആയിട്ട് നമുക്ക് ക്രാക്സ് ഡിറ്റക്ട് ചെയ്തിട്ടുണ്ടായിരുന്നു. അപ്പൊ നമ്മൾ ഈ മനസ്സിലാക്കിയെന്ന് വെച്ചാൽ, ഒന്ന് കോളം ഉണ്ടാവും, കോളം അതേപോലെ വാൾ ജോയിന്റ്, ഈ ജോയിന്റിലാണ് പലയിടത്തും ഇത് കാണുന്നത്. ശരിക്കും നമ്മള് പുവർ കൺസ്ട്രക്ഷൻ പ്രാക്ടീസാണ് ഇതിലൊക്കെ ക്രാക്ക് വരാൻ കാരണം. ഇപ്പൊ ഈ ശ്രിങ്കേജ് ക്രാക്ക് ആണെങ്കിലും അവിടെ ശരിക്കും മെഷ് ഇട്ടിട്ട് നമ്മൾ പ്ലാസ്റ്ററിങ് ചെയ്ത് കഴിഞ്ഞാൽ അവിടെ ക്രാക്ക് വരില്ല പ്രോപ്പറായിട്ട്. പിന്നെ ഹൊറിസോണ്ടൽ സെറ്റിൽമെന്റ് പറഞ്ഞ പരിപാടി എന്ന് വെച്ചാൽ, നമ്മൾ ഈ ഡിഫറൻഷ്യൽ സെറ്റിൽമെന്റ് പറഞ്ഞ സംഭവം നമ്മൾ കേട്ടിട്ടുണ്ടല്ലോ ഇത് സോയിലിൽ. ഇപ്പൊ നമ്മള് ഇപ്പൊ ഒരു ബിൽഡിംഗ് ഉണ്ടാക്കുമ്പോൾ നമ്മളെ നാട്ടിൽ നടക്കുന്ന ഒരു പ്രവണത എന്ന് പറഞ്ഞാൽ, പെട്ടെന്ന് നമ്മൾ എന്ത് ചെയ്യും, ബാക്ക് ഫില്ലിങ് സോയിൽ അവിടുന്ന് ഇവിടുന്നൊക്കെ കൊടുത്തിട്ടാണ് ഫില്ല് ചെയ്യും. എന്നിട്ടാണ് പെട്ടെന്ന് കോമ്പാക്ഷൻ ചെയ്തിട്ട് നമ്മൾ അടുത്ത പ്രൊസീജിയറിലേക്ക് കിടക്കും. ഫൗണ്ടേഷൻ പരിപാടികൾ ഒക്കെ സ്റ്റാർട്ട് ചെയ്യും. IS പ്രൊവിഷൻ വെച്ചിട്ടാണെങ്കിലും അല്ലാതെ ആണെങ്കിലും ഇപ്പോൾ നമ്മൾ ഇന്റർനാഷണൽ ഇപ്പോൾ ഗൾഫിലൊക്കെ പോകണമെങ്കിൽ നമ്മൾ ഈ കോമ്പാക്ഷൻ സംഭവം എന്ന് പറഞ്ഞാൽ ലെയർ ബൈ ലെയർ കോമ്പാക്ഷൻ അവിടെ ചെയ്യുന്നത്. എന്ന് വെച്ചാൽ 20 സെന്റി. നമ്മുടെ നാട്ടിൽ IS വെച്ചിട്ടാണെങ്കിൽ 30 സെന്റിമീറ്ററാണ് അറ്റ് എ ടൈം കോമ്പാക്ഷൻ ചെയ്യാൻ പറ്റുള്ളൂ. എന്ന് വെച്ചാൽ ഇപ്പോൾ ഒരു മീറ്റർ നമുക്ക് ബാക്ക് ഫില്ല് ചെയ്യണമെന്നുണ്ടെങ്കിൽ ലെയർ ബൈ ലെയർ കോമ്പാക്ഷൻ ചെയ്തിട്ട് നമ്മൾ അടുത്ത പ്രൊസീജിയറിലേക്ക് കടക്കാൻ പറ്റുള്ളൂ. നമ്മുടെ നാട്ടിൽ ടെമ്പോ അല്ലെങ്കിൽ ലോറി കൊടുത്തിട്ട് ഒന്നായിട്ട് മണ്ണാണ് തട്ടും, എന്നിട്ട് അതിന്റെ മേലെ ഒരു വണ്ടിയാണ് ഓട്ടുക, അല്ലെങ്കിൽ എങ്ങനെയെങ്കിലൊക്കെയാണ് കോമ്പാക്ഷൻ ചെയ്യുക ചെയ്യുന്നത്. അല്ലെങ്കിൽ റോളർ ഇട്ടിട്ട് 12 ടണ്ണിന്റെ റോളർ കോമ്പാക്ഷൻ ചെയ്യും, അങ്ങനെയാണ് നടത്തുന്നത്. അപ്പൊ ഇതെന്താ വെച്ചാൽ, ഇത് ഒരു 1 ഇയർ അല്ലെങ്കിൽ 2 ഇയർ കഴിഞ്ഞ് കഴിഞ്ഞാൽ എന്ത് ചെയ്യും, നമ്മളെ ബിൽഡിങ്ങിന്റെ വാളിലൊക്കെ വലിയ രീതിയിലുള്ള ക്രാക്ക് നമുക്ക് ഡിറ്റക്ട് ചെയ്യാൻ കഴിയും. ഒരുപാട് വീടുകളിൽ നമ്മൾ ഈ ഒരു സംഭവം, വീടുകളിലും നമ്മൾ കിഫ്ബിന്റെ സ്കൂളുകളിലുമായി ബന്ധപ്പെട്ട് സ്കൂളിനോടനുബന്ധിച്ച് കിച്ചൺ ഈ കിച്ചൺ ബ്ലോക്ക് എന്ന് പറഞ്ഞ സംഭവം ഉണ്ട്, അത് ഉണ്ടാക്കും. എന്ന് വെച്ചാൽ ഒരു ഫ്ലോറേ ഉണ്ടാവുള്ളൂ, പക്ഷെ എന്നിട്ട് അതിൽ പല സ്ഥലത്തും നമ്മൾ ഹൊറിസോണ്ടലായിട്ട് ക്രാക്ക് ഡിറ്റക്ട് ചെയ്തു. എന്ന് വെച്ചാൽ ഈ ലിൻഡല് അതേമാതിരി വാള് ആ ഏരിയ ഒക്കെ ഉണ്ടല്ലോ കംപ്ലീറ്റ് ആയിട്ട് ഹൊറിസോണ്ടൽ. അപ്പൊ എന്താ വെച്ചാൽ ഇതുപോലെ കോമ്പാക്ഷൻ പുവർ ടൈപ്പ് കൺസ്ട്രക്ഷൻ പ്രാക്ടീസ് അഡോപ്റ്റ് ചെയ്യുന്നതുകൊണ്ടാണ് ഇത് എന്നുള്ളതാണ് പിന്നെ മനസ്സിലാക്കാൻ കഴിഞ്ഞത്. എന്ന് വെച്ചാൽ പെട്ടെന്ന് വെച്ചാൽ ഈ കൺസോൾട്ടേഷൻ സെറ്റിൽമെന്റ് ഉണ്ടാവും 1-2 കൊല്ലം കഴിയുമ്പോൾ. കോമ്പാക്ഷൻ മാത്രമല്ലല്ലോ, കൺസോൾട്ടേഷൻ കാരണവും നമ്മൾ ഇതിന് സെറ്റിൽമെന്റ് സംഭവിക്കുന്നുണ്ട്. ഇത് കാരണമാണ് ഈ ത്രൂ ഔട്ട് ഈ ഒറിസോണ്ടലായിട്ട് നമുക്ക് അന്ന് ഡിറ്റക്ട് ചെയ്യാൻ കഴിഞ്ഞു. പിന്നെ വാളുകളിൽ കാണുന്ന നമ്മൾ ഈ ഡയഗണലായിട്ടും പല രീതിയിലും കാണുന്ന ക്രാക്സ്, അത് നമുക്ക് മെഷ് വെച്ചിട്ട് പ്രോപ്പറായിട്ട് ഇപ്പൊ ഒന്ന് ബീം പറഞ്ഞാൽ കോൺക്രീറ്റ് RCC ആണ്, ബീം അതേമാതിരി RCC, അതുമായി ബന്ധപ്പെട്ട് ഒരു ബ്ലോക്ക് വർക്ക് വരുമ്പോൾ അതിന്റെ ജോയിന്റിൽ നമ്മൾ എന്ത് ചെയ്യണം, പ്രോപ്പറായിട്ട് മെഷ് വെച്ചിട്ട് നമ്മളവിടെ പ്ലാസ്റ്ററിങ് ചെയ്യാൻ പാടുള്ളൂ. ഇത് ചെയ്യാത്തടത്തോളം കാലം നമ്മളെ നാട്ടിൽ ക്രാക്ക് ഉണ്ടാവും. അല്ലെങ്കിൽ നമ്മൾ മറ്റേ ഗ്രൂവ് ഇട്ടിട്ട് വേണം നമ്മളിത് ചെയ്യാൻ. നമ്മുടെ നാട്ടിൽ പ്ലാസ്റ്ററിങ് ചെയ്യുമ്പോൾ ഗ്രൂവ് ഇടൂല. ഒരു 40 സ്ക്വയർ മീറ്റർ അല്ലെങ്കിൽ ഈ ഒരു പ്രത്യേക എന്ന് വെച്ചാല് ഒരു ആസ് പെർ IS പ്രൊവിഷൻ വെച്ചിട്ടുള്ള ഏരിയ വരുമ്പോൾ നമ്മൾ എന്ത് ചെയ്യണം, പ്രോപ്പറായിട്ട് ഗ്രൂവ് ഇട്ടിട്ട് ചെയ്യണം. ഇതൊരു നമ്മളെ നാട്ടിൽ ചെയ്യാത്തടത്തോളം കാലം ക്രാക്കുകൾ നമുക്ക് ഒഴിവാക്കാൻ പറ്റൂല. പിന്നുള്ളത് ഈ എക്സ്പാൻഷൻ ജോയിന്റ് വരുന്ന സ്ഥലങ്ങൾ, എക്സ്പാൻഷൻ ജോയിന്റുകളിൽ പ്രോപ്പർ ട്രീറ്റ് ചെയ്തിട്ടില്ലെങ്കിൽ അതിലൂടെ ക്രാക്കും ഉണ്ടാവും, ലീക്കേജും ഉണ്ടാവും റൂഫിൽ നിന്ന്. അത് എന്ന് വെച്ചാൽ നമ്മൾ പ്രോപ്പറായിട്ട് അതിൽ ഈ
എന്താ സിലിക്കോൺ പോലുള്ള അല്ലെങ്കിൽ ഈ എക്സ്പാൻഷൻ ഫില്ലിംഗ് ആയിട്ടുള്ള സംഭവങ്ങളുണ്ട് പ്രോപ്പറായിട്ട്. അത് ഫില്ല് ചെയ്തിട്ട് അതിന്റെ മേലെ നമ്മൾ എന്ത് ചെയ്യണം, പ്രോപ്പറായിട്ട് അതിന്റെ ഉള്ളിലേക്ക് വെള്ളം പോകാത്ത രീതിയിൽ സ്ലാബ് 2 ഭാഗത്ത് റേസ് ചെയ്തിട്ട് കൊടുത്തിട്ട് ചെയ്യണം. അല്ലെങ്കിൽ പിന്നെ അതിന്റെ ഉള്ളിലൂടെ ഇത് വെള്ളം ഒലിച്ചിട്ട് അവിടെയും വാളിൽ ക്രാക്ക് ഡിറ്റക്ട് ചെയ്യും. ഈ ക്രാക്ക് ഡിറ്റക്ഷനിൽ നമ്മൾ മെയിനായിട്ട് അവോയ്ഡ് ചെയ്യുന്ന ഒന്ന് കോമ്പാക്ഷൻ പ്രോപ്പർ ചെയ്യാത്തിടത്തോളം കാലം പലയിടത്തും സെറ്റിൽമെന്റ് വഴി ബിൽഡിങ്ങിൽ ക്രാക്ക് ഉണ്ടാവുന്നുണ്ട്. അത് ആരും ചിന്തിക്കുന്നില്ല. പിന്നെയുള്ള ഈ മെഷ് ഇപ്പോൾ നമ്മൾ വീടുകളിൽ മറ്റേ വയറിങ് ചെയ്യുമല്ലോ, വയറിങ് ചെയ്യുമ്പോൾ ഇപ്പോൾ ഫുള്ള് നമ്മൾ ചിലവരെന്ത് ചെയ്യും, പ്രോപ്പറായിട്ട് കട്ടിങ് ചെയ്യില്ല, ഈ ഇതെടുത്തിട്ട് ഹാമർ എടുത്തിട്ടാണ് അടിക്കുക ചെയ്യുക, മൊത്തം കുത്തിപ്പൊളിക്കുക. അതായത് പ്രോപ്പർ നമ്മൾ ഗ്രൈൻഡ് ചെയ്തിട്ട് കോൺഡ്യൂട്ട്സ് അവിടെ ലേ ചെയ്തിട്ട് അതിന്റെ മേലെ നമ്മൾ ഇത് പ്രോപ്പറായിട്ട് ബൈൻഡിങ് വയർ വെച്ച് കെട്ടിയിട്ട് പിന്നെ അവിടെ പ്ലാസ്റ്ററിങ് ചെയ്യുമ്പോൾ അതിന്റെ മേലെ മെഷ് ഇട്ടിട്ട് വേണം പ്ലാസ്റ്റർ ചെയ്യാൻ, അല്ലെങ്കിൽ പിന്നെ അവിടെ ഒക്കെ ക്രാക്ക് വരും. അപ്പൊ ഇത് പ്രോപ്പർ ശ്രദ്ധിക്കണം ഞാൻ പറഞ്ഞത്. ഈ ഒരു പോയിന്റ് ഇതിൽ ഇൻക്ലൂഡഡ് ആയി കണ്ടില്ല, അതുകൊണ്ട് ഒന്ന് പറഞ്ഞോളൂ. എന്തായാലും
ആ പോയിന്റ് ഇതിൽ ഇൻക്ലൂഡഡ് ആകാഞ്ഞത് നമ്മുടെ ടോപ്പിക് ക്രാക്സ് ഇൻ കോൺക്രീറ്റ് ആണ്. ഇപ്പോ നിങ്ങൾ പറഞ്ഞതൊക്കെ ക്രാക്സ് ഇൻ വാൾസ് ആണ്. അതുകൊണ്ട് നമ്മുടെ ടോപ്പിക്കിലുള്ളതല്ല അത്, എങ്കിലും അത് ഒരു ഒപ്പീനിയൻ
പ്രാക്ടീസ് എന്നുള്ള ലെവലിൽ കൺസിഡർ ചെയ്യാം.
അങ്ങനെ മാനിക്കുന്നു. നമ്മുടെ മേജർ ടോപ്പിക് അതായിരുന്നില്ല.
സ്ട്രക്ചറൽ ആസ്പെക്ട്സ് ആയിരുന്നു. തീർച്ചയായിട്ടും
ക്രാക്സ് ഇൻ കോൺക്രീറ്റ് അതാണ് ടോപ്പിക്. അത് കുഴപ്പമില്ല. എങ്കിലും ഒരു ഈ ഇൻഫർമേഷൻ അറിയാത്ത പലരും ഉണ്ടെങ്കിൽ അത് അറിഞ്ഞോളൂ, അതിൽ തെറ്റില്ല. ഓക്കെ, താങ്ക് യു.
വെൽക്കം.
ഞാനൊരു ചെറിയ ടിപ്പ് നമ്മുടെ യങ്ങർ എഞ്ചിനീയേഴ്സിന്, നമ്മുടെ ഈ എക്സ്പാൻഷൻ ജോയിന്റ് പലയിടത്തിലും ഭയങ്കരമായ വിട്ട് കൊടുക്കുന്നതാണ്. 5, 6, 7 സെന്റിമീറ്റർ, 10 സെന്റിമീറ്റർ കൊടുക്കുന്ന ആൾക്കാരുണ്ട്. നമുക്ക് എക്സ്പാൻഷൻ ജോയിന്റ് ആ വിട്ട് കിട്ടാൻ ചെറിയ ഫോർമുല ഞാൻ പറഞ്ഞുതരാം. ഒരു തമ്പ്രൂളാണ്. LTC, ലെങ്ത് ആണ് L, T ഈസ് ടെമ്പറേച്ചർ ഡിഫറൻസ് ആൻഡ് C ഈസ് കോഎഫിഷ്യന്റ് ഓഫ് തെർമൽ എക്സ്പാൻഷൻ. അപ്പൊ അത് ഉണ്ടെങ്കിൽ LTC നമുക്ക് വിളിച്ചാൽ യു വിൽ ഗെറ്റ് 25 mm ഒക്കെ മതിയാവും, 1 ഇഞ്ച്. അപ്പൊ അത് പെട്ടെന്ന് കണ്ടുപിടിക്കാൻ പറ്റും. നമുക്ക് അതിന്റെ ലെങ്ത് പ്രകാരം അത് മാറും. അതാണ് LTC, ലീവ് ട്രാവൽ കൺസെപ്ഷൻ എന്നാണ് ഞാൻ ഓർത്തിരിക്കുന്നത്. അപ്പോൾ വളരെ സിമ്പിൾ ആണ്. ഞാൻ അതുകൊണ്ട് ടിപ്പ് പറഞ്ഞേ ഉള്ളൂ. ഓക്കെ, ഐ തിങ്ക് നമ്മുടെ ടൈമൊക്കെ ഔട്ടായി. ഞാൻ നമ്മുടെ ശ്രീ മഹാത്മക്ക് സാറിനൊരു മെസ്സേജ് അയച്ചിരുന്നു, ഞാനൊന്ന് പൊക്കോട്ടെ എന്ന് ചോദിച്ചിട്ട്.
സാറിനോട് ആർക്കെങ്കിലും പ്രത്യേകിച്ച് എന്തെങ്കിലും ചോദിക്കാനുണ്ടെങ്കിൽ അവർ ചോദിച്ചിട്ട് സാറിനെ റിലീവ് ചെയ്യുക. സാർ ഇപ്പൊ പോവാൻ നിൽക്കുകയാണ്.
വീട്ടിലാരുമില്ല.
സ്പെസിഫിക് ക്വസ്റ്റ്യൻ. നമ്മുടെ കൂട്ടത്തിലെ ഏറ്റവും ചെറുപ്പക്കാരനായ ആളാണെന്ന് ഓർക്കണം.
റണ്ണിങ് 79. I feel young at 79.
ആർക്കെങ്കിലും സ്പെസിഫിക് ആയിട്ട് ചോദിക്കാനുണ്ടെങ്കിൽ യു ക്യാൻ ഹാവ് ഇറ്റ്.
Otherwise, you can call me. എന്റെ നമ്പർ തരാം, 7293000900. You can ask doubts. 7293000900. പിന്നെ ഒരു യൂട്യൂബ് ചാനലുണ്ട്, വാൾസ് ആൻഡ് റൂഫ്സ് ബൈ ബേക്കർ അക്കാഡമി എന്ന് പറഞ്ഞിട്ട്. അതിനകത്ത് കുറെ ഈ സൈറ്റിലെ ടിപ്സ് കിടപ്പുണ്ട്. ഇറ്റ് വിൽ ബി യൂസ്ഫുൾ ഫോർ ദി പ്രാക്ടീസിങ് എഞ്ചിനീയേഴ്സ് ആൻഡ് ദ ഫ്രഷേഴ്സ്. കുറെ നാളായിട്ട് കേട്ടോ, പുതിയതായിട്ട് പുതുക്കാനും സമയം കിട്ടിയിട്ടില്ല. ഓക്കെ, ഐ തിങ്ക് സോ. ഇനിയിപ്പോ ഒരുപാട്
അവസാനമാണ്. But we are thanking you for joining us for this long.
Thank you very much. Thank you. Okay, thank you all. Good night.
Good night.
Thank you, sir.
ക്ലോസ് ചെയ്യാൻ തോന്നുന്നു അല്ലേ? 9:15
ആർക്കെങ്കിലും എന്തെങ്കിലും ഇതില് ക്വസ്റ്റ്യൻസ് ഒന്നും വന്നിട്ടില്ലല്ലോ? നമ്മുടെ ഇതിൽ വല്ല ക്വസ്റ്റ്യൻസും വന്നിട്ടുണ്ടോ നോക്കട്ടെ. One question to Dr. Adira. Which software do you use for crack modeling in your research? Dr. Adira is here. Dr. Adira ഏത് സോഫ്റ്റ്വെയർ ആണ് ഉപയോഗിക്കുന്നതാണ് ചോദിച്ചിരിക്കുന്നത്. ഡോക്ടർ
Hello.
Yes, it's question to you. Right. Which software you are using for crack modeling?
We don't do a lot of crack modeling.
Okay. So that question is not valid. One participant asked. Then another question is, will shrinkage crack extend from bottom to top of the slab? That was really answered actually. Pramod has answered it. It can extend, and of course it was mentioned. Shrinkage crack need not be vertical. It can be even inclined. It can be vertical. It can be inclined. It can be partial. It can be full depth. Shrinkage crack is not defined. Sometimes shrinkage crack may be attached to shear cracks also. Such possibilities are there. So shrinkage crack extend EM. That question is, it was already answered by Mr. Pramod. And another question is, if a horizontal crack originates from opening in masonry wall, in which category this may be classified? How can it be rectified? Actually, it's a masonry crack. It has nothing to do with concrete crack. Masonry crack can originate with even Mr. Jasim was telling. So many reasons. Settlement is one of the main reasons. Material imperfectness, even surface cracks can be there. That was answered. Then next one is. Sir, sorry, not heard properly on the reason why shrinkage crack extends from top to bottom of the slab. Shrinkage is a material property. So material property, if top to bottom the property is the same, the crack also will extend from top to bottom. It is possible. And normally shrinkage cracks are more on the surface, because shrinkage cracks are more caused due to temperature changes. That temperature changes will not affect the interior as much it affects the surface. So shrinkage cracks are mostly on surface, but there is no rule in hot season like this. It can extend the full depth, because inside also the temperature change can happen the same way. So no rule that shrinkage crack has to be limited. It is mostly on surface, but it can extend to any depth, and it can have different angles also. Then
brain shrinkage is volumetric change ആണ് സംഭവിക്കുന്നത്.
Yes. Right. And another note, on behalf of ICA Calicut Center, I congratulate BVIT team for organizing such an informative and interactive session, which is very relevant topic during this climate. Nice to hear from the stalwarts of construction and academics. From Sajid Bhaskar. So Sajid was here. He is the chairman of the ICA chapter, Calicut.
Yes, sir. I was here.
He is here.
Late, but
okay. Thank you for the comment. And we will have such programs together with ICA also. In coming programs, we can associate. We are an institutional member of ICA, and the ICA office is working in our campus. For your information, the ICA office is working in our college campus. Okay. So thank you for the comment. No more questions? Yeah, you can see Mr. Sajid there. He's the chairman of the ICA. Now you have handed over the charge of ICA, or you are still the chairman?
I'm still the chairman.
Still the chairman. Okay. Now we have crossed the time by 10 minutes. Any more questions from anyone? No more questions? We have crossed the time limit. So I think now we will hand over to the anchor for the conclusion.
Thank you all for your active participation. I now invite Krishnendu VP, Assistant Professor, to deliver the vote of thanks.
Good evening, everyone. It is my proud privilege to propose the vote of thanks for today's insightful webinar on crack in concrete organized by Vedavyasa Institute of Technology. First, I would like to express our heartfelt gratitude to our esteemed panelists, Dr. A.K. Abubakar, Dr. Adira Gobina, Dr. Raghu Kumar C, Engineer Ajit D, Dr. Nisha A.S., and Engineer K.O. Pramod. Thank you all for sharing your valuable knowledge and practical experience and expert insights. Your contributions have truly enriched this session and provided our participants with a deeper understanding of structural behavior and crack analysis in concrete. I extend my sincere thanks to our respected chairman, Dr. P.R. Sri Mahadevan Pillai sir, for his inspiring presidential address and continued support. I also express my gratitude of Professor Divya KK, Vice Principal, for a warm welcome and encouragement. A special note of appreciation goes to organizing team of Techsphere and all the faculty member and students coordinate whose dedicated effort made this webinar a success. I would also like to thank our anchor Nidhi today's session is ensuring the smooth flow of the program. Last but not least, the heartfelt thanks to all participants for your enthusiastic involvement and active interaction. Your presence made this session meaningful and engaging. With this, we come to end of today's program. We hope the sections have been informative and beneficial to all. Thank you, one and all.
Thank you
So good
everyone
night to
for
all of
joining
you.
us today.
We will meet again after 2 weeks with another program. Every 2 weeks, we are having a program like Techsphere. This is part of it. A technical topic will be taken up. It will be either a monologue or a dialogue like this, and we will have it every 2 weeks under the auspices of the college, Vedavyasa Institute of Technology, with some other professional bodies like ICI, like AC, like IEI. We associate with, and Mr. Ajit is there. We can associate with Grace also, because Pramod is also active in Grace. We have a bi-weekly program. Okay. Thank you all for joining us.
Thank you.
Good night.
Welcome.
Okay.
Thank you, sir. Good night.
Thank you, Dr. Nisha. Thank you.
സൗണ്ട് കേൾക്കൂല. ഹലോ.